Right. Yeah, okay. So, all right, I think today we talk about the bar model, as you can see. And we probably will be able to do it up to about, close about 4 p.m. to let you know. Because usually this workshop will last about close to 6 hours. Of course, in between there will be a lunch break. You don't worry, you know, the school will not keep you hungry here. Yeah, so I think we will do that. Now, I have some handout here. You can take notes, whatever that is, you know, as I go along, and so you can see, you know, what's going on in this bar model. Pass to the back, okay. Pass it to the back. Pass it to the back. There's some more here. Yeah, pass it to the back. Oh, don't have it here, sorry. Pass it to the back. Oh, one more, sorry. One more. Pass to the back. Not enough, raise your hand. I still have some more here. Anybody short? Short, okay, take it. Anybody short? Yeah. Two more can, no problem. 1, 2. There you go. Everybody can set. All right, you don't look at it first. Anyway, I will go through them, all the slides. Don't worry, one by one, and you know what I'm doing. Okay, so this is a workshop on bar model. By the way, bar model is from Singapore. In EDUSEEDS, basically for the primary mathematics, they've adopted the Singapore bar model. Okay, actually it's not Singapore bar model. I would call it Singapore math in general. Because Singapore math is more than just a bar model. Bar model is only one of the components in the Singapore math. There are other things too, okay? And at the end, I will tell you, there's another workshop that follow immediately after this one. These two workshops always go hand in hand. Of course, today I cannot do both. Possible. The same part. Of course, that one is not bar model anymore. It's something else. But today it's only for the familiar. Okay. How do you find it? Is it easy to use? Difficult to use? Come on, feel free to write. Yes, please do.
Easy to understand but hard to apply.
Hard to apply, okay. Yeah. I tell you what happened to the bar model in Singapore. Actually, bar model was introduced sometime in the early 80s, late 70s, about 79, 80s, that kind of thing. What happened is that, you know, there's a research team from Singapore. They go around the world and they study what's the best methods to help students learn mathematics. Because at that time, in Singapore, the kids have a hard time also learning mathematics, put it this way. So that's why the Ministry of Education sent out this research team there, look around, what's the best methods to do it? So they got lots of ideas here and there. Now when they come back, they sit down together, and lo and behold, they have created the bar model. That's a starting point. But eventually, as time passes, they add more and more to it. So now the bar model has become very much enriched, by the way. And also they added many other things which is not part of the bar model. As I say, I'll talk about that maybe another workshop. Okay, but today is only on the bar model. Now, when they first rolled out the bar model in the early 80s, and one of the things what they have to do is that they tell the parents, do not teach your kids mathematics for the primary math. You know why? Because the parents all learn from the old way. They know nothing about the bar model, by the way. So I say, if the school use the bar model to teach the students, and at home the mother or the father teach the kid in another way, and the poor kid get very confused. So don't do that, please. Leave it to the hand of the teachers. Okay, they've been trained. to teach the children how to solve word problems using the bar model. So that's what happened in the early 80s. Now, of course, until today, there's still quite a good number of parents, who still not knowing how to use the bar model. I don't blame them because they were not raised, in that era then. Okay. I've ever done workshops for parents, by the way. You know why? Some parents are very keen to help their own children. So say, what's this bar model? I need to learn something about it. At least at home, I can help my kids. Fair enough. So because of that, I have also done workshops for parents, besides the teachers. Okay, now, I have basically got 3 parts in my workshop. The first part is the introduction. Okay, I'll tell you briefly what's bar model. But the important question is, why must you use it? I know that some people tend to reject bar model. Why must I use it? There must be a reason. Then, of course, the second part now, that is the main content of the bar model method. There are different types of bar models. I will go through that with all of you one by one, okay? Now, last but not least, okay, you learn bar model, understand what's going on, but how to teach the students, the kids, to use bar model. So the last one is on the pedagogy. So very simple. I will break it down into these 3 components there, and that will be the order for the day. Now, by the way, if you have any question, feel free to raise your hand anytime. You can disrupt me, it's okay. I'm not clear what that is all about. Fair enough, okay? So please feel free to disrupt me. Oh, by the way, you are not going to listen to me for 6 hours. You'll feel very bored. So you're going to exercise later on. There's something for you to do. Because if you learn something, if you don't practice, you wouldn't go into your head. Okay? So this whole issue. Now, let me go on then. Just an introduction. What is the bar model? Well, I define very simply. It's a visual tool, by the way, that transforms word problem into a picture. So it's a transformation from words into picture. So this whole idea of the bar model. And of course, the word bar means what? You see a rectangular bar there. That's like the bar model. Very simple to understand. Okay? Now, that little bar, you can see that. What does it represent? It can be a known quantity or it's an unknown quantity. So that's basically what it is. Now, for unknown quantity, of course, in the problem there, you're supposed to find the unknown quantity. That's a way of handling math problems, right? So that's how you do it. Now, bar model, I said, is most suited for what? Word problems, not all word problems. Word problems on what? Whole numbers, fractions, percentage, ratio, decimals. So in other words, you will never use a bar model for rate and speed. No, you don't do that. So, but if you look at all these whole numbers, fractions, percentage, ratio, and decimal, it's basically the number system. Am I right? Everything about numbers. And one thing about the primary mathematics, numbers take up the most chunk of the primary mathematics. Am I right? They're supposed to learn how to use and manipulate the numbers. So that's why the bar model is very good for questions on numbers. Now, it helps you to solve arithmetic or algebraic word problems visually. That's the whole idea. It's a visual way of solving problems. Okay, I think one person coming in here. Hello. Why we teach bar model? Why must we use it? Why can't we teach problem solving the same good old ways? Why must we have bar model? I think got to do with our human brains. You see, our brain, whether you like it or not, we cannot change it. It's right inside you anyway. You and me, we all have a brain. But the brain is very good with pictures. Something you see, you understand a lot better than words. That's the whole idea, okay? It says the human brain processes and retains visual information more effectively than textual information. And that is true. Now, a very simple example that I can cite, you all have experienced it. When you go to a country for your holiday, whatever that is, you take lots of pictures, am I right? And you come back and you want to show your families or your friends where you've been to. Do you tell them verbally about the place there, or you show them a picture? Of course, the picture can speak better than what you can tell them. Am I right to say that? Yes. That means the picture can communicate your idea more effectively to the person than when you tell the person verbally without the picture. That's the whole idea. That's how our brain works. Our brain is good with pictures, but not so good with words and symbols. Put it this way. So that's why, you know, there's a purpose of the bar model here. Why? Words are abstract. As I say, pictures easier to understand for the brain. Do you understand what this word means? Syzygy. What's that mean? Oh, by the way, these words have no vowels, only consonants. Am I right? You say, what does that mean? Totally meaningless. No. You see all the planets all in one line there? That arrangement of the planets in one straight line is called syzygy. You see, the pictures speak better than the word itself. The word is abstract. With a picture there, I don't think I say a lot about it. Once you look at it, you understand the meaning of the word, in other words. So that's how, you know, you can see that, you know, why we need pictures. Now, let's look at our brain. I say that human brain processes visual data better than textual data. Why? Our brain can process image 60,000 times faster than texts. Put it this way. A lot faster. Now you understand why, you know, pictures are quite important for our learning. It takes 15 milliseconds for our brain to form the first impression. 15 milliseconds to get the first impression. That's one of the things you got to bear in mind then, okay? Quite fast though, okay? It's almost like a split of a second. Look at the picture, you can get it there immediately. 90% of information transmitted to our brain is visual. That's a fact. If you think for yourself, you walk around, whether you're driving, whether you're walking on the street, what kind of information do you get? It's all visual, am I right? Traffic jam, I slow down. If a big crowd there, I try to avoid. I mean, I will find another route to go wherever it is. Everything is visual. Okay? When you go to a restaurant, you look at the menu. What do you look at? Is the name of the dishes or the picture first? The picture comes first, what? Oh, I like this dish. How do I order this one? Hey, what's the name of it? See? Picture comes first. Because the first thing you understand is from a picture. So that's why I say, no, 90% of information transmitted to our brain is visual. How much can you retain in the brain, the information that you get? How big is the brain? Your memory capacity is what? 25,000 terabytes. Now we go to terabytes. Last time we go to gigabytes, now terabytes already. It's 10 to the power 16. Okay, 1 tera is the 10 to the power 14. Okay, to share with you. Okay, because of decimal 2.5, so it's the 2.5 times 10 to the power 16 bytes. Oh, very big though. That means your brain can store as much information as 5 sets of encyclopedia. Ooh, huge. Today, if you buy a hard disk, I don't think you can match this capacity. No way. You only get about what? 1 terabyte, 2 terabytes, 3 terabytes at the very most. Am I right? You never get 25 terabytes. Your brain has a lot more capacity than your hard disk. But the problem with us is that we store a lot but don't know how to retrieve. That is our problem, am I right? Ayah, where is it? I forgot. I've seen it, but I can't remember. That's where the whole trouble is. But we have lots of storage capacity. But it says that 95% versus 10%. Our brain can retain 95% of information from visual data, but only 10% from textual data. And now you see, if the poor kids only read the text and nothing else, there's not much that he can retain in his brain, put it this way, honestly speaking. But if a picture there, he will remember much longer. Of course, he will still forget, but at least, the retention period can be longer, put it this way. So that's the reason why you see visual data is very important. So, now, our brain basically receives both the visual as well as the textual data, both. We cannot run away from it. So these two types of data that come to our brain, we actually use them together. That means, somehow it's good that we need to have these two types of data. And it says that, visual aids, pictures, all these things, help us to what? Conceptualize, forming a concept, explore ideas to enhance our understanding. So that's what we are doing it. With our visual information like what? Diagrams, charts, models, etc., etc. Something that you can draw a picture. But text we also need it. Why? Because it provides a structure and precision. Very precise. 2.5, very precise. Okay? 10 grams, very precise. So we need the textual information also to provide structure and precision. So therefore, we use both the visual and the textual information together in our brain to enhance our learning, to enhance our understanding. So we don't throw away with the textual part, we need it to help us understand what we see from the picture. That's the whole idea about how our brain works. All right, so much about the reason why we teach bar model, okay? It's got to do with our human brains. Now, I'm sure that for primary kids, language can be a problem. Especially in Malaysia, I think many of you have encountered your students maybe coming from a Chinese school. When they come to your program, at EDUSEEDS, for example, when they can solve problems, word problems there, they read it, they don't understand what's going on in the word problems there. Okay, so therefore, I think, language can be an obstacle in the learning, especially for what kind of students? Sorry, what is this? Wait a minute, something is not right. I pressed the wrong key. Just give me a second. Yeah, it's back. Okay. Now, students who have low language proficiency, that's a fact. So therefore, I think if you want students to learn mathematics, even for other subjects, language is very important. You make sure that your students must build up the language foundation. That's important, no matter what they study, whether it's math, science, or anything. Why? Because language is a tool for communication. It can be oral communication, it can be written communication. Both, they need a good language foundation. So please make sure that, they must have a good language foundation. But how about those who already have no language problem? They're very well, they still have a second problem where they may not fully understand language used in mathematics. Math somehow have their own language. The way they say things, the way they express some of the things there, not quite the same as what we do in our everyday life. I can share with you some of the things that you can see that it's not quite the same. We may say it in this way, but in math, we'll put it in a very different way. Because why? Math have to express it very precisely. Sometimes in our daily conversation, we're not that precise. Am I right? As long as we get a message across to the person there, and that's it. Don't have to be so precise. But in mathematics, in particular, we've got to be very precise in the language. So that's the reason why, you know. So then the second one, even though they have no language problem, what do they have? They got a math problem. I understand every word in the word problem there, but how to solve it, I don't know. So that's the second problem. Okay, so that's the whole idea about it. By the way, anybody want to tell me anything about your student? Is it a common issue that you face among your students there? Yes, okay, it's the common problem you face. Now, so therefore, word problem is always the challenge. By the way, even though Singapore has been using the bar model for so many years, word problems is always a challenge. Whether it's in Malaysia, whether in Singapore, they are all the same. Actually, not only in Malaysia and Singapore, it's everywhere in other countries too. I've been to many countries. I've been to US, UK, and even in the Central Asia like Kazakhstan, Azerbaijan. I ask the same question. Word problems is always a challenge, like it or not. So that means words are very abstract. I don't care what language you use, whether you use English language, Chinese, or Malay, or any other languages, words is abstract. Aspect of life, okay? Not because of English abstract, same for any language. That's why we need pictures. So therefore, we use a bar model to help remove the language obstacle. That means the moment you transform or translate words into a bar model or picture, then the kids, oh, now I know what's going on. So when they solve a problem there, they no longer need to fall back to the word problems. Rather, look at a picture and use a picture to help solve the problem. That is the purpose of the bar model. Okay, so that's basically the reason why we do it in that way. And also we have them to understand the word problems a lot better. Okay, so much for the intro. Let's come to the bar model method now. These are the bolts and nuts that we are looking at. Now, basically, bar model starts from grade 2 onwards. We use it all the way to grade 6. Grade 1, we don't really have bar models, so to speak, but they do have a pre-concept of bar model. Why? Because they draw boxes. In grade 1, every little box that they draw there, or the square, you want to call it, whatever that is 1 unit. It's always 1 unit. Let's say if I have 5 pairs, or whatever that is, I will draw 1, 2, 3, 4, 5. So that's how they will do it. 3 pairs, they draw 3 boxes. Okay? So usually in the grade 1, this is about grade 1, you can let them have the real pair to play with if you want to. Okay? So after the lesson, they can eat the pairs. That's all right. Or you can give them counters, pretending these are pairs. By the way. Okay, let's use this to represent a pair, for example. So this is a counter to use to represent the pairs. At least the hands can touch the counters. Oh, by the way, touch is a very good way of learning. Don't underestimate touch. You may say it's very childish. It's not childish. Sometimes in learning, it's good to touch. Use the hand just to touch some of the things there. Don't forget, even for bigger kids, you say, how come so challenging? You want to touch the book? Yes, of course, you have to go touch. If a surgeon never touched a patient and operate, I only learn from the book, I know how to operate. Will you trust me? Thank you very much. You make sure that the surgeon has touched enough patients, am I right? Before you will let him operate on you then. Serious speaking, touch is important. It's a good way of learning. So, don't underestimate touch. Now, of course, they can also draw. Bar model is about the drawing, yes, you are right, okay? So this is what they will do in the grade 1. Now, of course, when they go to grade 2 onwards, instead of drawing so many boxes, they draw the bar of different lengths, okay? Okay, if I draw a longer bar, that means what? It's a bigger quantity. Shorter bar, smaller quantity. Simple. And now, when they draw 2 bars about the same size, you can put the dotted line there. That means what? This same length bar represents what? Equal quantity, same quantity. So therefore, I think now when your students learn to draw the bar model, make sure that they draw it properly. That's important. Now, kids sometimes they are not very careful there. Now just sketch it there, whatever that is. So what happens is that some people, you will use those dotted line to guide them. The boxes there, okay, you draw how many boxes, they will count, so they make sure that they are okay. But by right, eventually, they don't need those dotted lines there. They can straight away draw the bar model freehand. Just draw the bar model there. So you help them to learn how to draw the bar model. That's important, okay? So now they can see that now it's the length of the bar to indicate the amount of quantity, you know, that it represents. Now, for example, it said that Kim is 24 years old and Alex is 6 years older than Kim. How do you draw that? Now, Kim is older, of course the bar is longer. And Alex is younger, so it's a shorter bar. So fair enough, okay? Bigger number, longer bar, small number, shorter bar. So they will draw it. And they can put the number there inside. It's okay. Now, I don't care whether number 24 is inside the box there or it's above the box anywhere. It doesn't really matter. It's just an indication that, okay, the longer bar has a value 24. That's what it says. Now, how do you show that 6 years younger? It's a bit short, right? So this distance here is 6 years younger. Now you can see that this sentence, or rather, you know, this word problem here, you translate into a picture. And you put, by the way, don't forget to put the name of the people there. You have Kim and Alex. So now what happens is that when the kids look at this question here, it turns into a picture already. Now the picture is not easier to understand than words, put it this way. Am I right? It's very easy. And straight away they can tell, oh, then I can find any answer which I want. In other words, you can ask them, how is Alex? He can tell you straight away. You see, but the word itself, sometimes kids may not be able to figure out. Younger than means what? You know, they might have to think and process the word younger than, because these are words, abstract, you see. So there's a whole reason why we have the picture here now. This is a very simple bar model. There are 3 types of a bar model. You have the part-whole model, comparison model, before-after model. You may have heard of these 3. Let me go through with you all these 3, okay, and see what they are. Now, let's take the part-whole. Part-whole means what? Now, in mathematics, part-whole is a very important concept in general. Many areas you have part-whole. Part-whole applies to where? Fractions, percentage, ratio. That means I got a whole, I cut into little parts. That's all. Okay, now, the parts may be the same, may be different, depending on how you cut it. So this whole idea about the part-whole, okay? But in this case here, we just say that you have a whole, but it's made up of many parts. The parts can be an unknown, can be a known quantity, up to you. Of course, it's known quantity, that means it's given to you. You don't have to think about it. You don't know what the quantity is. Unknown usually is something you may need to find. What is the unknown quantity? Sometimes it can also be an unknown. They're given a part to find the unknown whole. That's another area here, right? So therefore, students always ask what? To find the unknown quantities. It can be a part or it can be a whole, whichever is an unknown. Now let's look at this one here. Out of 140 pebbles in a box, 87 of them are white pebbles and the rest of them are blue pebbles. How many blue pebbles are in the box? This probably is a grade 2, am I right? Is it grade 2 word problem? About grade 2, right? Okay, grade 2 word problems here. Now, how do you handle this one here? Well, they're supposed to translate into a bar model. Now, this is a part whole, right? I know the whole, 140 pebbles. There are 2 types of what? 2 types of pebbles, the white and the blue. Now, of course, here, because of the PowerPoint, I can color it blue, but of course, in the case of the kids, they cannot color it blue. It's okay, as long as they put down the label correctly. Even without the color, it's okay. Now, I know the white is what? 87, I put 87 here. The blue, I put a question mark, I don't know how many. Now, okay, up to this point, when the kids draw the bar model, you see that when I draw the bar model, I draw the white seems to be a bit longer bar and a shorter bar. Because I look at the number, compare 140 and 87, I know 87 is more than half of it, so I draw a longer bar and a shorter bar. But for the students, they may not rest immediately. They may draw the bar, they may draw this one to be shorter and this one is longer, or they may somehow draw it to be equal length. Now, don't worry about the accuracy of drawing the bar model. I don't care how they would draw it. They may draw the white to be a shorter bar and the blue is a longer bar, but the important thing is that they must put the right label over there, and the important thing also, the number must be put in the right place. You see that? So, once they get the right place, they can still find the answer. So, do not penalize the kids because of bar model. Don't worry about that. I will not penalize them. It only, once you draw this picture here, it means what? It shows they understand the words in the word problem. That's a key idea. Picture need not be perfect. I know sometimes, way back in Singapore, some teachers are very particular about the label must be inside or outside, wherever it draws the arrow. I said, this is a small matter. Don't fuss over this a little tiny detail. What we want is students understanding of what they are doing. That's a key idea. All right? We are not perfectionists. Now, once they do that, you see, when they look at this picture, they can easily find. It's basically to find this one, that these two make up 140, so therefore, this must be the difference of these two numbers. Am I right? They can see immediately, rather than read from words. So that's what I'm saying. Once they translate words into the bar model there, when they solve the problem there, they only depend on the bar model to write the solution. And that's all they take. And of course, the solutions are very easy. That's it. Now, of course, having said that, some students say, teacher, why must I draw the bar model? I know the answer. It must be 140 minus 87. I get the answer. Correct. Actually, many smart kids can do it immediately without drawing the bar model. Now, if they do that, are they correct? They are correct without the bar model. Because the actual solution is here, not the bar model. The bar model is only help them understand the question better. But when in the marking for the assessment or the exam there, you have to mark it correct, even without the bar model, number one. Now, reason why I asked them to draw the bar model, not because they cannot solve it, because I want them to practice bar model drawing. You know why I say that? Because if they always do without a bar model and solve the problem immediately, then one fine day, they come across another problem which they don't know how to solve. It's okay, can you draw a bar model for me? I say, oh, I don't know how to draw a bar model now. Because they never practice. So as they are going through a learning process, it's good for them to practice drawing the bar model. It's good practice. Even though they know the solution there, practice drawing it. Because when it comes to more complicated problems there, they make sure they know how to draw it. That's important. Now, of course, grade 2, grade 3 may be easy. 4, 5, 6, you know what I mean. The bar model can be a bit more tricky for them to draw. Okay, now we start from something very simple. All right, so there's a whole idea about bar model. A supermarket packs 336 peaches in small cartons. Each carton has 8 peaches. How many cartons are required to pack the peaches? Now, with a bar model, can kids solve it easily? Kids always get confused with these two operations, multiplication and division. Should I multiply? Should I divide? Perpetually it's a question there, okay? So, now, therefore, they want to draw a bar model. But how to draw this bar model? No. I have one box here. Each box represents a carton. Each carton has 8 pictures. So I put 8 there. So they're all the same, by the way. I can see that they're all the same size. I don't know how many, right? So I just draw the line here. Okay, I know that. I need so many cartons, okay, so I can pack what? 336 pictures. So question is that, how many cartons? Now it's also good to put something like this so that students will know what they're supposed to find. They're supposed to find how many cartons are needed. Now once they see that, then they can see actually, I got so many pictures here. Each one can take 8 pictures. If I were to divide it, I should be able to get the number of cartons. So that's why once you see that, it's a simple division which they can do it. You see that? So that's how they will do it now. We start something very simple. One thing good about teaching the bar model is that start something very simple for them to practice drawing first. Until they're so used to it, then it's okay. Okay? Then, this whole idea. Now, you can also do it for fraction. Fraction is the same. We can write 4 equal parts. 4 equal parts, of course. Therefore, each part. So you got 4, 1 make up a whole. And okay, we use this term. Times now. Are what? Equal quantities. Fair enough? Okay, so this is how you teach them how to. Oh, by the way, I think for us adults, it's very simple. Now, I think one thing about teachers, if you're a teacher teaching the kids, of course they know a lot more than the kids. That's why they come and learn from you, right? You say, oh, simple thing. I know already. No, don't forget, the poor kids don't know. You know, doesn't mean that they will know. So I always caution the teachers, when you are teaching the students, never see it from your own eyes. You must see it through the eyes of the students, how they see things. You may have seen this one 1,000 times, but the poor kids see that for the very first time. Don't forget. So therefore, as a teacher, the biggest challenge is not the content of the word problem. The biggest challenge is learn to see through their eyes. You lower themselves, see through the eyes. Then you realize the difficulty. Why do you not understand? You see that? So that's the whole idea. You know your multiplication table very fast. Okay? 7 times 8, come up with half mouth already. 7 times 8, go on the finger and count. You see that? So there's a difference between you as a teacher and the poor kids down there. Help them to understand. See through the eyes. Okay? That's all. This in the concerts, these are girls and the rest are boys. If 51 boys, these are in the concert. Oh my goodness. Hey, what grade is this, by the way? Who can tell me? Grade 2 or 3? Grade 4. Oh, grade 4. I don't know. Okay, grade 4. Okay, grade 4 so will be it. Do you think this word problem here will pose a little difficulty for the kids? It is, no. One thing about the bar model, when you read through it, even the earlier one that you see, it looks so simple. Do not jump right into drawing the bar model for the kids. Ask them questions. Let's say just now we have Kim and Alex. They'll say, how many people are there in the word problem? They say, Kim and Alex, let them tell you. And they will label it, Kim. They put it down on the board first. Okay, what do they have? Oh, Kim has 5 apples, Alex has 7 apples. Okay, go to the bar next to it. So you have to get it step by step. Of course, now because I'm training you teachers, I do it very fast. But when you do it for the kids, you do it in a slow motion. Slowly, okay? They may not be able to draw it immediately. Now, let's say, if you teach the kids to handle this one here. I said, oh, by the way, the word hole, only for your understanding. You don't say that in front of the kids. They know what's a park hole, by the way. You can say, a big pie, made up of many small slices. Oh, that's a park hole. Okay, they will understand that. Okay? Or cake cut into many slices, they can understand that. Park hole is very abstract, these terms. But for you people, you're adults, so I can use a park hole here. So now the question is, there are how many attendees, that means they want to find a hole, am I right? So therefore, in the concert, you have boys and girls. Okay, so boys and girls make up all the attendees in the concert. No. You see, sometimes you have to verbalize all these things before you draw the bar model. Don't draw for it immediately though. You don't appreciate this, okay? The concert, many people, we call that attendees. And among all these people here, we got boys, we got girls. And that's it, good. That's the first understanding. Once they will do that, how many girls are there? 2/5, how many there? What does it mean? There'll be 5 parts, right? Okay, so I will draw the bar model now. So once I understand that concept, I will draw this way. So these are all the attendees. The whole is there. And I know that girls take a what? 2 out of 5. So therefore, I think before they can do the bar model, that concept make them learn topics, am I right? For the primary kids. Fraction. And these 3 are what? Inseparable. They all join together. I call it these are 3 muscles. So therefore, but I will have to stop this 3. Correct label, and the label 50. Things are a lot easier to understand already. How many must what? One box is 5, I got. So one unit times attend. Attendees in the concerts. Up to you, want to ask them. So that's a bit tricky, but now you can see that, the picture helps them to understand. The word problems are a lot easier. So final question, by the way, okay? Feel free to disrupt me as I say, just raise your hand. You told me this is a grade 4. Huh? Grade 4 or grade 3, sorry? 4.
I think grade 3, more advanced grade 3.
Grade 3, yeah?
More advanced grade 3. But sometimes grade 4 also they cannot handle this.
Okay, yeah. All right. Now, this is about ratio. Sharon and Tim share a bag of rice by mass in the ratio of 2 to 3. Now, this is about ratio. As I said, ratio, fraction, percentage, they are all the same. They are all cousins, by the way. Okay, they're all cousins, I call them. Now, when they see that, 2 to 3 means what? If you got 2 parts, I get 3 parts. The parts must be on the same size. Am I right to say that? Okay? If you got 2 apples, I must have what? 3 apples. 2 to 3. Okay? If you have 4 apples, I must have what? 6 apples. So they will know that. That's important, okay? So when you teach them the ratio now, over here, I assume they'll learn the concept of the ratio. In learning ratio, they also know what we call equivalence ratio. Equivalent. 1 to 2, same as 2 to 4, same as 3 to 6. All these things they will learn equivalence ratio. And many times they are asked to what? Simplify to the simplest ratio. So there are many times asked to do the simplification. But over here is 2 to 3. Now, so 2 to 3, they share a bag of rice here. Sharing got what? 2 parts. Tim has 3 parts. So that's how they draw the bar model for ratio now. Looks almost like the same as a fraction in a way. It's true. So you can say that if you talk about the mass of the bag, there you know, Sharon has what? Has 2/5 of the rice. Am I right? Yes. If you talk about the fraction, it's 2/5 of the rice. Tim has 3/5 of the rice. So you can see how ratio and fraction, actually they are quite connected to each other. Now the whole idea in learning mathematics for kids is to learn how to connect concepts. Please do. They are not isolated. It's not, oh, fraction is fraction, ratio is ratio. No, they're all interconnected. You can go from one form to another form and vice versa. Okay, so that's how they draw the bar model for ratio. Now let's look at this question here. The red and the white paints are mixed in the ratio of painting. It be too dark or lighter color, whatever that is. And the mix together is a. Now after you mix it, quick, so we liters how many liters? I'm right to say that they got no patience to wait and see. Brain, so they to think very hard. See, I must solve it. Then somehow they try to solve it, they look at it, how to solve it? Then they get stuck. Okay, my advice to you, if you really want to question, please hide the last question. How many liters of, just point there, go further. Because once you solve, you know what you want. Am I right? Context of this here. I want to understand, you know, the mixture of the ratio of 4 and the total amount of the mixture is 18.2 liters. I want to see that. And from learn to draw the bar. So it's always good to hide the question first, learn to draw the bar. They will solve it. Yeah, the kids are going to do psychology. You know, their nature is I want to solve it immediately. So you okay, now once they've done that, you will draw 3 to 4. 3 to 4. I got the red paint, I got the white paint, same as the earlier picture that you see. Total is 18.2 liters. So you will draw this picture here. Then picture. Now what is for? I don't know how many, but I know all make up 18.2. So straight away, earlier about the rice. Am I right? Very similar. They can see it. So once they solve it now, one thing about, yes?
Is it necessary to put a question mark in order?
No need. But if they want to, you can put question mark there, yes. Yes, okay, you're right. They can put a question mark there, okay? You can put a white there. White, how many? Good idea. Because you know why if you don't put question mark, the kids may give the wrong answer. He give the red paint instead of the white paint, am I right? Yes, please put a question mark there. By the way, it's not hard and fast rule, but it's good practice, okay? Good idea. Yes. Now, it's always good when you do that. It's always reduced to 1 unit. Before you start multiplying it to the number of units that you want. That is important. You are given some units, having a quantity, you reduce it to 1 unit before you multiply how many units that you want to get your answers. That process, we call that the unitary method. There's a name given to it, unitary method. It's a term that we use. Of course, you don't have to say it in front of the kids. You don't understand what it means. But for you, I just share with you that this is called the unitary method. Always reduce to 1 unit before you find your answer, whatever that you want to find. Okay, so that's how they will do it. So you can see that from a picture, the kids can do it a lot easier than straight away from the words and to the solution. Now you see why we need the bar model to help them understand the word problems. Ravi gave 1/3 of a weekly pay to his mother. Okay? He gave to his mother. And then he spends 2/5 of the remaining amounts on the grocery. Now the key word is the 2/5 of what? Of the remaining amount, not the original weekly pay. Whatever left, he spent the grocery, and what's left, he still have $96. How much was his weekly pay? Double arrow there, okay, the "the" is going to be there. Now, that means how to draw this bar model. 1/3 and 2/5. Now remember, when they first learned fraction, the concept comes from where? Part whole. Equal parts make up a whole. But in this case, you got fraction all right, but the wholes are different. Different wholes altogether, that's important, the kids. Don't see it as the same whole. Sometimes the same whole, sometimes a different whole, so the kids don't get confused. Okay? So therefore, how are they going to draw this bar model? Now, can they do it without the bar model? They still can, but a lot more difficult. So with the bar model to draw, and how to draw this bar model? Now, you're not sure how to draw a bar model? I will show you how to draw it. First of all, you draw this one here. That's easy. This initial pay, right? Here's the weekly pay. And he give what? 1/3 to his mother. So it's okay, mother get 1/3. So he's left with 2/3. This is the original whole, am I right? This is the original whole, the weekly pay. Then what happened? He spent 2/5 of the remainder now. What's the remainder? This is the remainder. 2/5, that means I take this thing here, I chop into what? 5 parts. Am I right? But I can tell you one thing, and start doing it, the whole bar model can look very messy. Because you already draw 2 boxes, very nice boxes here, and then chop into 5 parts. Then how to chop? You know, right? It's not easy to divide these 2 big boxes into 5 smaller. Therefore, I adopt this, what you call the drop-down bar. I don't know how to draw it, but I just drop down, same length, okay? Another blank one, I draw into 5 equal parts. We call it a drop-down bar. You follow me? It's the same. That means these 2 bars are the same as these 5 little ones. Drop-down bar. Now, once I do it, I have a very clean bar here for me to chop it into 5 equal parts. And I know that he spent 2/5, this 2/5, right, of the remainder. This part is on grocery, and after that, he's still left with $96. It's a lot neater now, and it's much clearer. Now they can see that this is the remainder. Now, of course, if you want, you can label it remainder. Up to you, remaining amount. They are free to label. In fact, if they will get confused, they can put the label here. This is what? This is the weekly pay, remaining amount. Fair enough. If they want to label it in that way, perfectly all right, because it shows that you really understand the question here. So, you know, so the whole idea is this. Now, once they see that, I think things are a lot easier to solve already. Because what it's supposed to do, fine. Now, how much is weekly pay, right? It's original. So I put a question mark there. So in other words, how should they solve it? This question, they're supposed to go from here all the way back. We call that method what? Working backward. They work backward. From the remainder here back to the original whole. If I know that only this part has numbers, this part always have no numbers, right? So I will use only this. This is for the original amount there, this part here. So that means I have 2 units is 160, 1 unit is 80. I got 3 units, 80 times 3, 240. So that is the final answer. This is the way how you use a bar model to solve it. You see that this unit and this unit are not the same. Am I right? So the picture helped them to figure out how to draw the bar model. Hello, is it too complicated for the kids? But you got to teach them now. Obviously, they wouldn't know how to draw it immediately. Am I fair enough? You teach them how to draw this bar model. But you see that the bar model makes it very clear, very easy to handle problem solving. But through the picture, you see, when I do it, I don't only look back the original question, no more. I look at the picture and try to write out slowly. Now, of course, initially, they may struggle a bit to draw the bar model, but let them practice a few more. Okay? Usually, you will give them a few similar questions to practice how to do it. You should, the first one, explain the whole rationale, how to do it. Let them practice. Okay, so there's a way to do it. What time is our tea time? You know? 10 what? 10:30 or what? 10:30. What's the time now? Huh? 10:25. Okay, I go for a few more minutes and then maybe I finish the park hole, then I will go for the tea break. Come on. Yeah. Okay, now, maybe I think I talked too much already for this morning. Maybe it's time for you to exercise your brain. These are the 5 questions here. I think it's in your notes there. Okay, these are all for park hole. Okay, some are easy, some are not. I would say that it's a bit more involved, okay? Not really challenging, but it's a bit more involved. You can try any one of them now. You try them, okay? Maybe about 10 minutes. When you go for a break, you come back, you carry on. Then you show me your solution on the board later on then. All right, how about that? Okay. Label it. can do. You see the pictures. And hey, don't be shy.
Students do the same mistake as this.
Ah.
Are we judge them wrong because of
The units. You should maybe a fraction of a mark, a quarter or something like that. It's not a serious mistake. Yes. Okay. Them that wrong, by the way, because when you have quantity divided to each other, whether it's divided by liters, you don't come with liters, you come up with times, or it's a quantity, how, in other words. So that's basically what it is then, so that you bear in mind. Yeah, okay. You want to try number 3? Okay, come. I think you try the red one is better. Yeah, try the red one maybe. One's not very clear. Okay, thank you.
Sorry for the handshake.
It's okay. Yep. Well, okay. Let's read the question again, okay? The chef bought 180 kilograms of rice for his restaurant. He used up 2/5 of the rice on the first day and 33 kilograms of rice on the second day. How much was left for the third day? So he has 180, but 2/5 now. The 2/5, let me ask a question. What is the whole? 2/5 of the 180, right? That's important. 2/5 is not, if it's the same one, 2/5 is the thing. This pound is the whole thing. You must bear in mind. It's the whole thing. Okay? So therefore, if I were you, what I would do is that I will divide the original 180 into what? 5 parts, am I right? So I will divide into 5 parts, okay? How come this one got two, into parts. 1, 2, 3, 4, 5, right? Into 5 parts. Okay? Then I know that the first day, he used what? 2/5, that means what? This for the first day, right? Okay. You see, the way we do it as we read, we just do it step by step. First day. But second day, 33. You say, but 33, I don't know. Where should I draw? Is it one box or two? So I don't know where it is. I know somewhere along the line. I don't know where it is. I mean, it's from here. Somewhere along the line, I don't know where they are, how far they are, I have no idea. But this is what? 33, and this is what? Second day. Am I right? That's all. I don't know how far it is. It doesn't really matter. But I know that after that, whatever left from here onwards must be for the what? Third day. Am I right? I haven't solved the problem yet. I just draw the arm to present it. Because here talk about 3 days, first day, second day, third day. The question is that how much now you can see that the parts are equal. First part that equal after, right? But say 3, no idea. Does it really matter? It doesn't matter because all you do is find out how much you use up for the first day, right? So the way you do it is what? You take the first day, so the right for the first day must be what? 2/5 of 180. Quick for me. 72. The second day, it's given to us. We don't right. We know what's to us. Rise for the second day. What? 30 kg. Am I right? So that much. So therefore, left must be what? Must be 180 minus 7 minus 33. Now, one thing, if the kids are not, how can I go? Something minus something there. Some of them don't know how to handle this kind of situation. Don't worry, I can erase it. I don't have to do it this way. For us, you have to write one more. Right for the first 2 days. How about that? I know two days. Oh, easy. It will be what? 72 plus 30. Am I right? Together. So I will have 104. 33. Okay. No. For third day. For for the kid. For those who use the minus 33, write one more step. It's for the sake of the children, not for ourselves. Now you can see that even though I don't know work this much. You see, the first thing is important. You take the whole into 3 parts. Okay, then third day. And from there, they write all these things here together. Yes?
Is it preferable to put unit measurement like kg?
In the bar model? Okay. That is optional. The reason why I didn't put it there because it will look very cluttered. You see, what is important, the bar model, is to show all the numbers, where the numbers come from. That's the only thing you have to bear in mind, okay? Yes. You can put in there, nothing wrong with it. But sometimes because you have no space to write so many words there in the bar model there, so write the number rather than, you know. But when you work it out, this one they must put in all this. Just that they put it into the, okay? Now, very good question. What if the question has 2 different types of units? You have kg and grams at the same time. And that is important. If you have kg and gram at the same time to do a bar model, then your units is important. But however, if you don't want to put the units, the kids must convert, listen very closely, all to a common unit. Whether he would convert to or gram into kg. That is important. Because when you draw the bar model, you put all the numbers there, you make sure that they mean the same thing. In this case, everything is kg. It's okay. But if this is a kg, this is a gram, then there's something different already. So they must do the conversion very closely. Let's say if instead of saying that, let's say instead of saying 33 kg, I say 33 grams, for example. Then in that case, if I put 180 and 33, that can be quite misleading though. Because this is kg, this is in grams. You can't draw it in this way. Of course, you say, okay, I put G, this is a gram. You can also do it that way, but kids cannot. 2 different types of units. So you don't want to do do it that way. So of course, maybe it's easier for me to convert everything to grams. In that case, if you want to everything to grams, what should I do? I must add in 100 more zeros. 3 more zeros. That is okay. 3 all become grams. Oh. Now, everything in terms of grams. Then look at the answer. It also give the answer in kg. You must connect kg. So that's the whole idea. But you make sure that in the bar model, the units all must be the same. Else it looks very confusing. Yes. Bear it in mind. Okay. So depending on the types of question that it comes out. So these are little details we have to watch out for the kids. Yeah. Okay. Good. Number 4, anybody? No taker, okay, you want to take it, good. Oh, the marker. I think Yeah, thanks. Okay. By the way, straightforward this one, right? There's a one little thing a teacher will ask me. When they work the answer, write the last line. That's always the question. Some teacher insist you must draw the line. Here's the answer. Well, some say that my answer is here already. What? Come on. You must write out the sentence there. Okay?
Solution sentence because there are multiple answers and there's
You put this. Arrow, there's the answer. That's it. You follow me? So some kids they have all kinds of ways of. You can, I think. Sometimes lazy to try to be words. So student. All right. Yes. I got nothing against. I think it's a good idea. But the reality is that kids are simply too lazy to say. Teaching this answer already. Why must write another sentence there? So that's as I say, these are no hard and fast rule. I think even our Singapore the national examination, the PSLE, our primary 6 or grade 6, at the end of grade 6, before they enter secondary, they must pass the national examination, which is PSLE, which stands for Primary School Leaving Examination. And they pass it, then only secondary. So this kind of a situation there, the markers are more lenient. As long as you give the right answer, the approach is correct, credits there. Of course, in school, if you want them to put in this statement here, that's wrong also. They make them very consistent. So that's how we look at it. Okay, now the last one is numbers. You got whole numbers. You got together. One question. Okay, good. Okay. Let's look at the question again. Among the 270 people in a ballroom, 40% of them are men, and the rest are women and the children in the ratio of 5 to 4. How many children are there in a ballroom? I'm going to find the number of children this time around, okay? Yeah. Now, so at first I think we'll break the bar model into men and the rest. And they put down 40 over 10, 6 over 10. By the way, I think when you do that, that means the kids know exactly how to convert percentage to fraction. That's important. All right, so that's how you will do it. Fine. Then later on, he used the drop-down bar, which is good because it's talking about the rest, right? So among the rest there, what did they have? Okay? For the women and the children, it's divided in the ratio of 5 to 4. So he has 9 units there. He said that children take out 4 units. So that's basically what it says. And he worked out the percentage. Of course, the work out is 162, so he can work it out there as such. So there are 2 parts here, by the way. All right, good. Now, one other thing about now, the bar model perfectly correct. Nothing wrong with the bar model. Okay? Sometimes the kids are lazy to draw such a complicated bar model. Yeah, teacher, don't look so complicated. Okay, let us be more merciful with the kids then, okay? Yeah. The kids may decide to do it this way. Instead of saying 40 over 10, why don't simply put down 40% and 60%? Quickly, I can do that. Am I right? I can put down 40% and 60%. They will do it that way too. Fine. They can also do it in that manner. There's nothing wrong with it. It's the same as 6 over 10, 4 over 10. It's the same thing. So if they do it that way, it's still fine. Now, when they come to this part, of course, we see that this is a ratio 5 to 4, and they say, okay, just hold divide the 9 into 9 parts because there are 5 parts to 4 parts. They say, but say your teacher had to draw lots of boxes there, and what they can do now, these kids are getting a bit smarter. Same box here, they would do it in this way. Okay? Then they will do it knowing the kids, they will do it that way. Instead of dividing, this is perfect, all right, nothing wrong with it. But kids who are lazy, they say, teacher, I know. This is 5 over 9, this is 4 over 9. They can do that because that means if they do it that way, it shows that the concept of ratio is very good. Why? Because he knows that 5 to 4, the whole must be 9 units. He knows it must be 9 units. Same as how you divide into 9 units here is the same. So if we do it in this way, then he can figure out it's for the number of children. You see that? So if the kids were to draw it instead of this way, in that way, this one to replace this one here, is perfectly legitimate. So they can do it this way, fine. Faithfully draw the 9 boxes there. But for those who want to say, I don't draw just 2 boxes, 5 over 9, 4 over 9, case closed, then take this one, multiply by 162, you get the answers. So they see there are many variations in drawing the bar model. So as a teacher, you must be flexible enough to accept, be open-minded to accept the way they draw the bar model, the way they solve the problem. Any questions so far? Okay, good. Now, this is about the bar model, about the part whole model so far that you have seen. Of course, since it's a workshop, we had to run very fast. But of course, in the classroom, you go a bit slower, with the student here and there, fair enough. That question, as I said, probably for the grade 6, right? Grade 6 kids, okay. Okay, let me go on. Comparison model. Now, comparison model meaning that you compare 2 or more quantities together, and there are basically 3 types of comparison model, 3 types. Then let's go through each type of them slowly, one by one. There's not only one type, but 3 different types. of comparison model. The first one is called the additive comparison model. How to add together. Now let's look at it here. 54% of the members of a book club prefer reading fiction over non-fiction. The book club has 500 members. Find the difference in numbers between those who prefer reading fiction and those who prefer reading non-fiction. So you compare these two. Very straightforward. Usually when you talk about comparison, your label will do it in this way. Fiction, non-fiction, they will do it in that way. They will draw the bar. Now they look at it. 54% of the members prefer what? Fiction. That means the bar will be longer than the non-fiction. Am I right? So they draw a longer bar and shorter bar for the non-fiction there. They find the difference. That's the whole idea. Okay, find the difference. Now once this one is drawn, the answer is quite straightforward. Now this type of comparison is called the additive comparison model. So here's the answer. Straightforward. It involves nothing more than just what? Simple addition, subtraction to get it. That's why it is called comparative model. Okay, additive comparative model here. Very straightforward. Clear? Fair enough? Now, the next one is called the multiplicative comparison model. You see kind of a wording. Alex has 3 times as much money as Ben. Now, whenever they see this, how many times? 3 times as many as Ben. Okay? As many as or as much as. These two phrases, kids must understand what it means. Now, for those who have a language problem, explain to them what does that mean. 3 times as much as. You got 2 persons here. You have Alex, you got Ben. Who has more money? You ask this question. You say, okay, Alex has more money, Ben has less money. How much more? How much less? You will ask this question. Okay, Alex has how much more than Ben? 3 times. What does that mean? That means if Ben has what? $1, Alex has what? $3, 3 times. Okay? If Ben has what? $5, Alex must have what? $15, 3 times. So these are kind of expression they must learn to get used to it. Now, once at that, okay, the total sum of the money is 572. How much money does Alex have? Now, how do you draw this bar model? If you look at it, three times means what? Ben has 1, Alex has 3 times, 3 boxes. So that's how you would to draw it. Okay, how much money does Alex have? The total is this one here, so straight away you can work it out. Altogether, count the number of boxes here, 4 units. Again, unitary method, you work out 1 unit, then you work out Alex with 3 units, and say Alex has what? $429. So that's how you do it. This is called the multiplicative comparison model. We're going to compare the number of times. The first one is called additive because you do addition or subtraction. Follow me? So that's these 2 types here. Quite straightforward, these 2 types, but they're not the same type. Am I too fast? Oh, it's all right with you? Hello, if I'm too fast, please slow me down, okay? No, just not a coffee break. Now we are a bit earlier than the coffee break. Okay, so now we will pass this one. We go to the next one. Okay, this is a multiple comparison model. Now, this is a bit complex. Watch out this one closely. In a basket, the watermelon is twice as heavy as the cantaloupe and is 7 kg heavier than the pineapple. The cantaloupe is 3 kg heavier than the pineapple. What is the mass of each of the fruits? My goodness. You got 3 types of fruits now. You got watermelon, you got cantaloupe, and you got pineapple. And they all have different masses, okay? Some heavier, some lighter, whatever that is. So that's called a multiple. Why? You have to compare so many things all together. Now, how do you draw this bar model? Okay, now let's see how to draw the bar model. I will explain to you how to draw this bar model later on, okay? Now let's look at it. Watermelon is twice as heavy as the what? Cantaloupe. And is 7 kg heavier than the pineapple. The cantaloupe is 3 kg heavier than the pineapple. Stop there first. If you were to look at the bar model, do you have any question? What do you expect the student to ask you? Come on. If let the kid look at this one, the kid, huh? How do I know I must put the watermelon first, followed by the pineapple, followed by the cantaloupe? Why can't I put the watermelon, cantaloupe, pineapple, or pineapple, cantaloupe, watermelon? You see, that's a question they will ask you. Teacher, how do I know which one to put first? Don't ask, it's like that. Please, there must be a reason. The reason is, now I share with you very quickly. This one looks very innocent, yeah, quite natural, but there's a reason behind. You see that the pineapple is between the watermelon and the cantaloupe. Why? Because of all the trees, that has the lightest weight. It's the lightest. Am I right? Everybody compared to pineapple, watermelon, and cantaloupe, they are both heavier than pineapple. I purposely put it in the middle so that this pineapple can be used for comparison with the watermelon at the same time with the cantaloupe. That's the reason why I put it in the middle. You see that? So the first thing, explain to the kids the reason why you want to arrange it in this manner. Now, assuming when you put out this one here, you don't show them the bar model first. Now I draw the bar model. How do I draw the bar model? Now look at it. I compare the watermelon with the what? Cantaloupe. So twice as heavy, that means if I have 2 boxes here, there's only 1 box here. I can draw same length. You see that it's the same length here. That's important. You draw the same length. But it is what? 7 kg heavier than a pineapple. So it's a pineapple is a smaller one. So it's a 7 kg heavier than the pineapple. You see that? That's the reason why. Now next one, talk about what? Cantaloupe is 3 kg heavier than the pineapple. So the bar is longer, so this part must be 3 kg. Am I right? That's how you draw the bar model. So when you teach them, the first thing is to tell them why you arrange watermelon, pineapple, and cantaloupe in this order. After you have done that, you go back to the question there and then start drawing the bar model. Do it in 2 stages. Don't do it all in one go. The kids don't know. I don't know how you draw the bar model. They will ask this question. I'm talking about pedagogy now, how to teach the kids in drawing bar model. Once you have that, of course, they're supposed to use the bar model to solve the problem. Now, one unit is equal to what? 7 minus 3. 2 units is what? 4 times 2 is 8. So the watermelon is what? Is 8. How do I get that? Because I know what? Because I know that the watermelon is 7 kg heavier than a pineapple. Am I right? So I know that. So I can do it that way. Okay? Now, so I will do it that way straight away. I can work out my watermelon and my cantaloupe and my pineapple weight. So the pineapple, of course, you can see is the lightest compared to all the other 2 fruits as such then. Okay. Never mind, you take it down first, okay? You can think about it later on then because I have to move on fairly quickly over this matter there. Yeah. This is, again, it's a grade 6 question, by the way. The earlier one usually is for the grade 4 and the grade 5. The additive and the multiplicative comparison as such. Excuse me. You know why 1 unit is equal to 7 minus 4? Minus 3, sorry. Any question? Hey, how come nobody asked me questions, stranger? If you don't understand why they raise, I say, I don't know why it's 7 minus 3 is equal to 1 unit. I said, do you understand why 1 unit is equal to 7 minus 3? I asked this question. Where is my 1 unit? Hello? One box like this, isn't it? This box, isn't it? Yeah. This box is 1 unit, so there are 2 units here. I must find the length, the quantity of 1 unit. That is my 1 unit. But why 7 minus 3? 7 up to here, am I right? 3 is here. Am I right? 7 minus 3, 4. So this is 4. You see that? Are you with me?
After I see the answer, one thing confuses me is that maybe it's the shape of the pineapple.
The shape of pineapple, why?
Because 4 and 1, the shape a bit confused, so I was thinking 1, but the logic is there.
Yeah. By the way, the drawing had to be a bit more precise if you do it that way. You're right, okay? So when you draw it a bit more careful because now you're comparing 3 different objects, or 3 fruits rather. And the first thing, purposely, I put the pineapple in the middle because that is the lightest of all and it can be used to compare with the watermelon and the cantaloupe. So I put in the middle and I can label all these things based on the question I do it there, okay? But then my question is, I must find out what now. The key idea is that which box should I take to be 1 unit? That is the important question. You look at the numbers here, the easiest one to find 1 unit must be the big rectangle here, the big box, am I right? Because we see there are numbers here about the big box. The small one, I don't know what that is, to be quite honest. I can never find out what that number is. But the big one I can find. So I called it to be 1 unit. So it's a 7 up to here. Since here is 3, I shorten it, become what? 7 minus 3 is 4. So I know this is 4 units. So 4. So the 1 unit is a 4 here. So this obviously must be 2. So it must be what? 8 kg. You follow me? Once I know 1 unit, I can easily work out what that one is already. See, I can work the cantaloupe. So I can work the cantaloupe with 4 kg and the rest 1 kg, so on and so forth. This is how you work it out. Still look puzzled?
So there's one thing I want to ask. So is it like you've done the first sentence first, so you draw on the first sentence first before you go for the second one?
Sorry, I beg your pardon?
So for this question, there's 2 sentences, right? 2 information.
Yeah, that's right. So they have this one about, first of all, you compare the watermelon with the pineapple, first thing. Okay? By the way, the watermelon compared with pineapple and also compared with the cantaloupe, both. Whereas the cantaloupe is only compared with the pineapple, only once. Yes.
So going back in that order, right? So before you...
They can, okay, now this label, the way they do it, they can straight away, they can use second one, they can straight right now, this one is easier, they will put it in this way first, up to them. Okay? Yeah. But they know that, you see, the comparison is this. First of all, you compare watermelon with cantaloupe. So it's 2 boxes versus 1 box. They will draw it. Then they will take the pineapple. The pineapple, they can see that, oh, cantaloupe is what? 3 kg heavier. So I can see that it will be shorter, 3 kg here. Am I right? But then the watermelon will be what? 7. So that's how they will do it. It doesn't really matter whether they do the 7 first or the 3 first or 3 first followed by the 7. It doesn't really matter. It's how they think. This whole idea, how they think. But the key point is they must determine or decide which box is to be used as 1 unit. And that 1 unit, the way they want to choose, it must have a value or a number in it. So they look at it. you only have two types, either the longer box or the shorter box there. They find that the longer box, I can find a value there a lot easier. So I choose 1 unit to present the longer bar there. You follow me? So that's how it works. So this is called the multiple comparison model. All right, you have both the additive here as well as the multiplicative comparison together in the one question. I think you can find some of this question in your grade 6. What problems there? Yes, okay. This one. About age, huh? Same thing. Okay, give another one. Among 3 ladies, Betty's age is half Anna's age, while Chloe's age is three times Betty's age. The total age is 84 years. Find the ages. 3 ladies, different ages, okay? Now, again, let me ask a question. Who's the youngest? You have Betty, you have Anna, you have Chloe. Who's the youngest? Betty. Betty's the youngest, right? Yeah, so Betty's the youngest, so probably, I said, in that case, I'll put Betty in the middle. Am I right? Most likely. So yes, fair enough. Okay, let's see whether the bar model goes in this way. I'm not sure. But yes, Betty put in the middle there. You're right. You see, this one looks almost the same as the earlier one. Almost the same. Not the same, but almost the same. Okay? Because one thing good about this is that, all these are it's a multiplicative comparison here. Anna's is what? Twice as old as Betty. Am I right? 2 times. Twice as old as Betty. Chloe is what? 3 times as old as Betty. So just nice. So this is a model comparison using the multiplicative comparison model with 3 persons in one go. The total age is 84. I think from here, once they look at the picture or the bar model, it's easy to find a solution there. Because they're all the same length, right? All these little bar are the same length. So I'm sure that this part should be quite straightforward. I don't need to explain it anymore. Am I right? So you can see that, the bar model literally can really, transform the words into the picture, and a lot easier to understand than if you look at the original words, it's hard to be honest, the kids find it hard to solve. Even we adults also find it hard to solve sometimes, am I right? Of course, yes, I can use algebra. Of course, I can use algebra to solve it. But don't forget, this poor kid have not learned algebra yet, Okay. No, secondary one.
Like
year 7, yes. They don't use the bar model anymore, no more.
But if your bar model foundation is no good, okay?
No. Okay. There's always a question posed for those who are not good with bar model or those who have not learned even bar model. Let's say they join right into grade 7 from other school. And from other school, they have never learned bar model. And the straightway join into grade 7, and grade 7 literally don't use bar model anymore because everything starts from grade 7 onwards is algebra. My advice is that to these students there, we do not force them to learn bar model because it will not be used from grade 7 onwards. Then in that case, you see, the whole purpose of grade 7 is to build a firm foundation in algebra because they need that all the way up for grade 8, 9, and 10, all the way up there. So make sure that they have a good foundation in algebra from grade 7 onwards. But those who are coming from the primary, who have been using bar model for so many years, and they are very familiar with it, we have to provide them a transition from bar model to algebra. I do have a separate workshop, how to transit from bar model to algebra. Because the same issue faced by Singapore students when they graduated from the primary school, entering into secondary, and suddenly the math teacher in secondary class there, let's do it in algebra. And the kids say, huh, how to do it? Huh? I'm using a bar model. So you know what the poor kids do? They see the word problem there. They're not good, by the way. They're just not strong in algebra yet. What they will do, they're very smart. On a piece of paper, they read the question, they draw the bar model, they look at it, they start putting the X, Y, Z, and then copy it from bar model and put it into the solution there for the teacher. So the teacher would not see what they do. They hide the bar model there, but they show the algebra. But using the bar model to create those algebraic equations to solve the problem there. Now, of course, they can do it. That is the reason why we have to provide a transition for the grade 7 from bar model to algebra. Now, that transition is a temporary. What does transition mean? What? Once you get over it, bye-bye. I win off the bar model. It's like a baby. After some time, you win off the milk bottle anymore. No more milk bottle to drink from the cup. Same. Not that because bar model is no good, because you don't need it anymore. Once we have algebra, let's go on algebra. Put it this way. So that's why the answer is, for those that have no function in bar model, and they come to grade 7, start with algebra straight away. Okay? Yeah. Only for those who are coming from the grade 6 onwards, and then use the bar model, you have to transit over. So it's a matter of transition at the end of the day. Okay, now, since now we're talking about only for the primary mathematics, so that's why we talk about the bar model. When it comes to secondary, I will do a different thing altogether, okay, for the students. So we can find out all the age there quite easily for this question. How about you try this time around now? You try. You try the question? Come on, anybody try the question here? Hey, where's the cloth? Oh, here, the answers here. You done yours already? All the 5? You do all the 5?
Yeah.
Good. Are you okay? Can draw the bar model? Yeah. Okay. Are you okay so far? You've been using bar model before? So you know how to do all this thing. Good. How about you? Okay, your bar model? You can do them? Good. I know you're very good in doing the bar model. What's the time now? Let me see. How did you manage to do it?
All from EDUSEEDS.
Hmm?
They are all from EDUSEEDS. All of them.
They're from different centers all over. I don't know where they are from.
New teachers.
Different places. I don't know where they're from. Some are new. Most of them are new teachers anyway. So, yeah. So how do you find the problems here?
Good.
You think that your student can handle it?
Should be good. Yeah.
But depends how you want to teach them.
Yeah. See, I think this will be a very good
Huh?
intro to go in. Yeah. Because in Singapore, a lot of them they just
Jump.
very hard questions.
No.
Rote learning. Still low.
No.
Yeah.
You see how to rationalize it slowly, step by step, to get them through.
Yeah.
There's no road running here. Yeah. How do you find? Okay so far? Is it the first time you're doing the bar model or what? You used it before?
I used it before.
Okay, good. But how do you find the student taking it? Are they okay?
They get confused.
Do you find that this way you can make it clearer for the kids there? Yes. Okay, I think it's about lunchtime now. I've just paused for the lunch. Before we do that, now let me have a word. I think all of you can draw the bar model quite well. Most of them, okay? Actually, for you people, it's not an issue of drawing the bar model. You are teachers, you are adults, you understand it very quickly. The issue is not so with you, it's with the students. What you know will not benefit the students unless you know how to communicate to them, they know what you are doing. That is a challenge to all the teachers. Am I right to say that? Yes. And you don't let them go and memorize drawing the bar model. Drawing bar model is not by rote learning, no way. As they do it, you know, they learn how to think, how to rationalize it. As you see just now, I go in a very slow motion, not because you people are slow. I'm doing it because I try to mimic what it should be done in the classroom. You follow me? So that's the whole idea here. You know, I find all the final points here and there, what you need to watch out for when you deal with the students. That is the thing I would like you to learn. Not so much of whether or not you know to draw the bar model. That one is easy. So you bear that in mind, okay? This is the purpose of this kind of workshop. Okay. Now, before further ado then, why don't we break for a lunch for 1 hour? Now it's about 12. We're back here about 1. The lunch is outside here. All right? The food are ready. Yeah, let's go. Come on. You need to charge up your battery. Okay, go ahead. Yeah. Stop for a while. Anyway, yeah. Let your mind rest. Later I will use some of the PSLV questions.
Yeah, later.
Later we come here, akan datang.
Is it those killer one?
Huh?
Is it those killer questions?
Not really.
Jesus opened my eyes, now I can see the light. I'm so glad he changed me, now I'm walking.
mercy meets me in the morning. The Holy Spirit got me feeling like I'm a kid on the weekend. Like, oh, ain't it good to know that everything's in your control? And oh, what a peace of mind. You make everything alright. Something about your presence makes me feel good. I don't have to worry about a thing. Even when the wind and waves are rising, I know I'm safe and sound in your love. I know I'm safe and sound in your love. Oh, Holy Father, Son, and Spirit, you deserve the praise. I was in that water headed for an early grave. Couldn't catch your breath and was on me like a weight. So you took me up, now I'm walking on the waves. Like, oh, ain't it good to know that everything's in your control? And oh, what a peace of mind. You make everything alright. Something about your presence makes me feel good. I don't have to worry about a thing. Even when the wind and waves are rising, I know I'm safe and sound in your love. I know I'm safe and sound in your love. I'm saved and free in every way, standing on you night and day. I'm safe and sound, safe and sound. I'm saved and free in every way, standing on you night and day. I'm safe and sound, safe and sound. Something about your presence makes me feel good. I don't have to worry about a thing. Even when the wind and waves are rising, I know I'm safe and sound in your love. I know I'm safe and sound in your love.
I'm a ship without a shore, sinking to the ocean floor, falling deeper, deeper. There is nothing I want more. Feel the rush of ecstasy, water's crashing over me. Barely breathing, breathing. You're the only air I need. Back and forth emotion, striving for devotion. I'm lost in your love. Gravity is breaking, everything is raging. I'm crossing boundaries, drifting to the violet, ebb and flow of silence. I'm letting go. You're all I live for. When I'm lost in your love, far beyond the earth and sea, lost in new realities. I am living, living at the point of no return. It's your love I can't ignore. This is nothing like before. Steady dreaming, dreaming. You're the world I see and more. Back and forth emotion, striving for devotion. I'm lost in your love. Gravity is breaking, everything is raging. I'm crossing boundaries, drifting to the violet, ebb and flow of silence. I'm letting go. You're all I live for. When I'm lost in your love. When I'm lost, when I'm lost in your love. When I'm lost, lost in your love. Maybe the streets are gold and there's a table with plenty room. Maybe we don't grow old and we got nothing to lose. Maybe in the promised land there's a choir when you walk through. Oh, but I pray heaven is like rain on a tin roof. Maybe the sun don't set and the waters don't rise. Maybe we don't forget how to laugh like a child. Maybe in the promised land we're all made for what we do. Oh, but I pray heaven is like rain on a tin roof, washing away my sorrows, giving me faith to follow a new tomorrow. They tell me in the promised land there are mansions to choose. Oh, but I pray heaven is like rain on a tin roof. Maybe time stands still and the mountains just move. Maybe we all have wings and there's only good news. Oh, inside the living water is the fountain of youth. Oh, but I pray heaven is like rain on a tin roof, washing away my sorrows, giving me faith to follow a new tomorrow. They tell me in the promised land there are mansions to choose. Oh, but I pray heaven is like rain on a tin roof, washing away my sorrows, giving me faith to follow a new tomorrow. They tell me in the promised land there are mansions for me and you. Oh, but I pray heaven is like rain on a tin roof. I pray heaven is like rain on a tin roof.
It's not just a story, it's a living, breathing, walking testimony of a God so good he'd leave his home in glory for the world he loved, for the world that he so loved. Hey, it's not just a story. Yeah. I believe in the life of Jesus. I believe that he conquered death. I believe in the resurrection. I believe he's coming back again. I believe that his spirit's with us. I believe that he gives us power. I believe that he is the Son of God. I believe it. I believe it. I believe it. I believe it. If I said I got here on my own, I'd be lying. 'Cause my eyes have seen the goodness of the Father. Oh, we're the ones He loves, we're the ones that He so loves. Oh, and I can't deny it. Oh no, say I believe in the life of Jesus. I believe that He conquered death. I believe in the resurrection. I believe He's coming back again. I believe that His Spirit's with us. I believe that He gives us power. I believe that He is the Son of God. I believe it. I believe it. I believe it. I believe it. I believe in the life of Jesus. I believe it. I believe it. I believe it. We cry holy, holy. Let the earth rejoice. He is worthy of all praise. Yeah. We cry holy, holy. Let the earth rejoice. He is worthy of all praise. Yes, He is. I believe in the life of Jesus. I believe that He conquered death. I believe in the resurrection. I believe, say, I believe that His Spirit's with us. I believe that He gives us power. I believe He is the Son of God. I believe it. I believe it. I believe in the life of Jesus. I believe in the life of Jesus. I believe, yes I do. Oh, I believe it. I know you are for me, but sometimes it's hard to believe that you're working things out for me. But I can't see, I can't see. I'm walking with blindfolds on, but you're more sure than the ground that I stand on. I know that you won't cave in. So I trust you, even when I can't see the full plan. Everything seems to make no sense. I know that you're in control, I trust you, even when I don't understand. My life is in your hands. I know that you're in control, You make ways out of nowhere. You've been faithful all my days. So why do I doubt when you say you would never leave me, you would never forsake me? Nah. You know my every need before I can say a thing. Your promise is yes and amen, yes and amen. So I trust you, even when I can't see the full plan. Everything seems to make no sense. I know that you're in control, I trust you, even when I don't understand. My life is in your hands. I know that you're in control, You got me, and you never let me go. I don't have to worry, don't worry, 'cause I know you're in control. You got me,
trust you, even when I can't see the full plan. Everything seems to make no sense. I know that you're in control, in control. I trust you, even when I don't understand. My life is in your hands. I know that you're in control, in control. This feels like rain. This feels like fire. This is like hope, too good to be true. This is a dream, I'm finally living, and all of this because of you. This feels like joy. This makes me happy. This feels like soul, rhythm and blues. This is the gospel of Sunday morning. And all of that because of you. So I'll give my heart over and over again, over and over again, over and over again. Oh, I'll give my heart over and over again, over and over again. This feels like love. It's not gonna hurt me. This feels like trust. I believe that is you. And this is a song that I love singing. So if nothing else, here's what I'll do. I'll give my heart over and over again, over and over again. Yeah, I'll give my heart over and over again, over and over, over and over. Listen. When my back was against the wall, figured I would be the last one that you would call. But you did it, and I'm glad that you didn't stall. I just put it in your hands and you did it all.
Behind dough, number one was the mansion, the clothes, and the bling. Number two, money, power, and control like a king. Couldn't see behind dough, number three, but I chose it by faith, cause Jesus was holding the key. Bizzle. I wouldn't change a thing.
I'll give my I'm gonna give it all. Give it all. Yeah. Gonna give it all. Oh. Na 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 na
Things are getting real, Jesus take the wheel. Only way I'm getting to the other side. Days are getting dark, life's a little hard. Blinded but I'm trying not to lose sight. I don't got this, I know you got this, yeah. And I believe it before I see it, yeah. I know you're gonna see me through it. If anybody can, you can do trial and the pain, fire and the rain. You're gonna see me through it. You're gonna see me through it. If anybody can, you can do it. And whenever my heart burns away, you say that then you're gonna see me through it. When the sky falls, who am I gonna call? The one who put it up there in the first place. Full scale attack, devil on my back. Better lace him up and go put on my game face. I don't got this, I know you got this. Yeah, and I believe it before I see it. Yeah, I know you're gonna see me through it. If anybody can, you can do it. Gotta know in the trial and the pain, fire and the rain. You're gonna see me through it. You're gonna see me through it. If anybody can, you can do it. And whenever my heart burns away, you say that then you're gonna see me through it. Our God is bigger than all our problems. The only one who knows how to solve them. So if you're sitting in the back, rock bottom, prayers in the air if you got them. Our God is bigger than all our problems. The only one who knows how to solve them. So if you're sitting in the back, rock bottom, prayers in the air. 'Cause I know you're gonna see me through it. If anybody can, you can do it. Gotta know in the trial and the pain, fire and the rain. You're gonna see me through it. You're gonna see me through it. If anybody can, you can do it. And whenever my heart burns away, you say that then you're gonna see me through it. Yeah, I know you're gonna see me through it.
Hey, Lord, I lift my hands. I give all the praise to you. Everything I am, you gave me the strength to do. Hey, Lord, I lift my hands. Lord, I lift my hands. I give all the praise to you. This is my response for making me brand new. Hey, Lord, I can feel your presence, putting all your peace in me. Lord, I can feel revival, breaking all the captives free. And though it sounds crazy, man, I used to hate me, till I met somebody who told me how he made me, how he died to save me. And if you want the same thing, all you gotta do is just say, hey, Lord, I lift my hands. I give all the praise to you. Yeah, everything I am, everything I am, you gave me the strength to do. Yeah, you do. Lord, I lift my hands. Lord, I lift my hands. I give all the praise to you. This is my response for making me brand new. And I can't help it, I'm just being real. I just walk up to the mic and tell y'all how I feel. Y'all think I'm religious, I'm just trying to eat a meal. But I don't live on bread alone, you hear it in my zeal. Down bad, but you got me better. G-O-D, that's the best 3 letters. Where you got me moving, I'ma need Rosetta. Keep your head up. Hey, Lord, I lift my hands. I give all the praise to you. Everything I am, you gave me the strength to do. Lord, I lift my hands. I give all the praise to you. This is my response. Oh, this is my response. Oh, this is my response for making me brand new. Stains have been
church on Sunday, just a kid never knowing that someday every worry I'd find would follow me all of my life. Nervous sitting there in the classroom, the teacher saw that I was brand new. I will never forget every word that she said. She said, Jesus loves you, no matter who you are, no matter where you go, you're not alone, he's in your heart. You're a child of heaven, he's known you from the start. He made you in his image and he set your life apart. I pray you always remember how much Jesus loves you. Now I struggle to believe I'm worthy, 'cause I'm anything but deserving. All the voices of shame from the mistakes that I made. But a stranger who barely knew me told me there was still more to my story. This is not how it ends. And I heard what he said when he said, Jesus loves you, no matter who you are, no matter what you've done or where you've been, he holds your heart. You are forgiven, he took the cross for you. He died and rose again so you could find your life new. I pray you always remember how much Jesus loves you. How much Jesus loves you. Walking in the church on Sunday, my daughter standing close beside me. All the things that I felt, she feels them as well. She's holding my hand so tightly at the classroom door before I leave. I knelt down next to her, whispered the very same words. I said, Jesus loves you, no matter who you are, no matter where you go, you're not alone, he's in your heart. You're a child of heaven, he's known you from the start. He made you in his image and he set your life apart. I pray you always remember, Jesus loves you. Jesus loves you. I pray you'll always remember how much Jesus loves you. Jesus loves you.
Yeah. With foes on my left and fears on my right, they think that I'm all by myself in this fight, but they do not know the infinite size of the God who is by my side. Hey, under fire, but my Goliath standing in the shadow of the Almighty. I ain't lying, just testifying. Man, I'm talking about a big God, big God. When trouble comes around the way, only remedy for big odds is a big God. Ain't nobody gonna shake my faith. No, I'm not afraid. Throw my hands up in praise for the times that He pulled me through. I'm counting on a big God that they can't stop. He's a big God. Why in the world would I worry away when I know that He holds my world in His hands? The monsters I face don't make me afraid when I know that I'm standing right next to Him. Man, I'm talking about a big God, big God. When trouble comes around the way, only remedy for big odds is a big God. Ain't nobody gonna shake my faith. No, I'm not afraid. Throw my hands up in praise for the times that He pulled me through. I'm counting on a big God that they can't stop. He's a big God. Than your brokenness, than your dreams not seen yet, than your greatest fear. It's so much bigger. When I couldn't get up, I could always feel your love. You're picking me up. I can always feel your love. Man, I'm counting on a big God, big God. When trouble comes around the way, only remedy for big odds is a big God. Ain't nobody gonna shake my faith. No, I'm not afraid. Throw my hands up in praise for the times that He pulled me through. No, I'm not afraid of the things that I face, 'cause I know what I've seen Him do. I'm counting on a big God that they can't stop. He's a big God. You're a big God. You're a big God. Hey, yeah. I know we got a, yeah, we got a big God. And what can wash away my sin? Nothing but the blood of Jesus. What can make me whole again? Nothing but the blood of Jesus. Oh, precious is the flow that makes me white as snow. No other fount I know. Nothing but the blood
I can't catch a bird that don't want catching. I can't make it sing its song for me. Freedom all alone, well that's a cage all its own. Freedom on your own ain't really free. No, little bird, that ain't what it means. And I won't take the wings you're used to having. I just wanna brush them with my hands. Freedom all alone, well that's a wing made out of stone. Freedom on your own ain't really free. No, little bird, that ain't what it means. Even freedom needs some fences. Even blue skies need the ground. Though you think it's gonna hurt, even you, little bird, need the feeling of coming down. I don't want the colors that you're flashing. I know that's what everybody sees. Freedom all alone, well that's a way to never show anybody what's really underneath. No, little bird, that ain't what it means. 'Cause even freedom needs some fences. Even blue skies need the ground. Though you think it's gonna hurt, even you, little bird, need the feeling of coming down. Freedom all alone, well that's a cage all its own. Freedom on your own ain't really free. No, little bird, won't you come on down to me? There is a table filled with the best food. Can you hear the Father calling? There's a seat just for you. And at this table, all is forgiven. Trading your chains of bondage for crowns of freedom. All are welcome at the table. There is a place just for you. No condemnation at the table. There is a place just for you. Just for you. Are full of love, and it's never ending. And at this table, there are no orphans, just a loving Father and His sons and daughters. All are well. No condemnation at this table. There is a place just for you. There is a place just for you. You are patient, you are kind, so I thought I finally got it right this time. You are lovely and full of life, but honestly I felt it wasn't right. I know my heart will feel the same again in time. I don't wanna give up on love, up on love. I know I'm not alone, but when I'm alone it's so rough and did so much. Took a chance, it didn't really work out. Doesn't mean that there's nobody to find now. I don't wanna give up on love, up on love, up on love.
Are you sure there's no more? I think some empty seats there. All come in. No more already, Okay. Okay, let's get going because I have to finish it before 4. Okay, just now before lunch, I think we have these few questions here. Okay, you try some of those. 1 or 2, okay. Anybody want to try some of this for me then? Come on. Now, since it's after lunch, I think it's better to get up and walk around. Don't just sit here or come on. Don't be shy. Anybody? Oh, you want to do it? Come on, you do it for me. Don't be shy, come on, do it. Try. First one, that's easy. Okay. All agreed this one? It's very straightforward. Am I right? No. This is a comparison model, yes. All right, okay. First of all, I think you ask the children, first of all, to write down the objects here. Basically, these are the what? The curry parts and the chicken parts. Put down that label first when they do it, before they draw the bar model. Then as they read, they just draw the whole thing. Once they got this picture here, this part is very easy already, straight away. Okay? Yeah, ask them to do a bit slower so that they will get used to it. The first one is easy. Okay, I tell you what, I wouldn't go through all of them, just pick a few. How about number, which one? How about number 3? Anybody? 3. Come on, don't be shy. No taker, no try. Number 3, come on. You want to try? You try. Okay, number 3. Okay. This bar model is a combination of bar model and the working all together at the same time. That's what she's doing, you know. It's a hybrid. Okay, usually we separate the bar model. Okay, let me tell you one thing about the bar model and the solution process. The whole purpose of drawing the bar model is to make them conceptualize what is in the question there, not solving it yet at this point in time, to ensure that they thoroughly understand the question. You see, the whole issue is that we do not want the student to jump right into the solution process. The problem with the kids is that if you do not have a proper understanding of the problem, let alone solving it. Am I right? So the purpose is for them to conceptualize the word problem and translate it into a pictorial form, which is the bar model. And from there, then only they figure out the solution process. If you combine the two together, I think it's very challenging for the kids. I must be able to draw it at the same time. I try to solve it at the same time. You follow me? So that's the whole purpose of it then. So don't forget about this whole point. When they're drawing a bar model, they should not think about solution yet. They think about what is in the problem. I want to understand what's going on inside there. That's the main message. All right? So don't forget about this. Now, if you want to draw a bar model for this one, how would you do it now? The way that she put it down is that she put down the ruler, the pen, and the glue. Now, let me read it one more time. A pen is 9.18 cm long. The ruler is 3.47 cm longer than the pen. Okay? So the ruler is shorter than the pen. And the glue stick is 5.26 shorter than the ruler. What is the length of the glue stick? So you want to find the glue stick then. That's what we want to find. So how are we going to draw this bar model? Anybody else have a different way of drawing the bar model? Come on. You have, okay? You show it now. Okay. Let me erase this part here. You draw it this way.
This one is still okay. 2 and 4 is difficult.
Never mind. It's just right here. Okay. That's a bar model. Okay, good. No. Am I right? The pen is what? The pen is 9.18 long and the ruler is 3.47 longer than the pen. Okay, good. 3.47. That's a very good picture of it. And what? The glue stick is 5.26 shorter than the ruler. Okay. Does it represent the whole question that it is? You see that? Have you solved it? No, not yet. You see that? That's the purpose of the bar model. I try to understand it. I try to understand the problem through a picture. Now I start solving it now. I'm trying to find this one here. So that's the whole idea. So how are they going to find it now? Once you look at this one, do you think the kid at least one step closer to the solution? You want to find how long is this one? Am I right? We don't know how long is this one. But you see, the way that he is doing it is that what? Everybody compare with the ruler. So therefore, I will, if only I know this total length here, I should be able to know this one. Am I right? It's how the mind will work. Huh? Once you know how the mind works, writing out is just a matter of mechanically just write it down, to be quite honest with you. So the only thing, to find this one, if I know this one, this length here, if I take away this one, I will have this length, obviously. So it's a simple subtraction issue here. But how to find this length? But you see, this length is the same as this length. But how about this length? Oh, I know this length is what? It's nothing but the pen's length plus this number here. So in other words, see the way they written, I'm supposed to find this length. Now, let's start repeat. I'm supposed to find this length. But how to find this length? But this length is the same as the length of the ruler. Correct. But I don't know the length of the ruler. How do I know? I compare the pen. Now I look at the pen. I know that the length of the ruler must be 9.18 plus what? 3.47. And that's how they figure it out. I just verbalize it now. Can you follow me? Once the kid can see in that way, it's a matter of what they think, write it down step by step. That's all it takes. Are you clear? So that's how, yes?
So I have one question. So in this case, it's not necessary to put the shortest at the middle, right?
Sometimes it does. That's why it's not always. You're absolutely right. But even if they do it that way, it's still quite okay. But you're right. It's not because if you look at the question, everybody compare with the longer one. Yes. You see, the whole issue is that you must find a common one where everybody start comparing with that one item there. So usually when I compare that one item there or one object there, I usually tend to put it in the middle so I know how to compare them a lot easier. Don't whether it's long or short. You follow me? So these are kind of a thing. So that is basically the way to help them to draw the bar model. These are little details. You have to help them to understand how to draw. Sometimes the kids say, I want to draw, but I don't know how to draw it. Because they don't know, what should I put first? Should I put the pen first, ruler, glue stick, or should I put the ruler first, pen? So they get confused. 2 is easy. 2 object is easy. But 3, a bit sticky, okay? If a 4, that's even worse. So I think this is the whole issue here. But usually I think for primary school, they go up to 3 at the very most. 3 is the max already. If you have 4 or 5, I think the kid, they go groggy already. So, okay, so I think that is the whole issue here about how to draw the bar model. Now you see why the bar model is only translate the words into a picture. They have not solved the problem yet. But from there, they do thinking. This is called thinking skill. Reasoning is a form of a thinking skill. One of the thinking skills is called reasoning. So in other words, you want the kid to do reasoning in the head. Well, once he reads out step by step, that's what I'm telling you, what follows is just a matter of writing it down, line by line. How they think, how they write, in other words. But of course, there's another issue here. Some kids can think but don't know how to write also. Now that you had to help them. Because they are not good with expression. Oh, teacher, how should I write it? You know, what words should I put down there? Because they have some language limitation, and that's where you can come in to help them. But before you help them, you ask them, tell me, can you reason out the solution process. You tell me how you think. If I tell you, oh, I will have to find this one, all this thing here, then you know that the mind thinking is very logical. So your job is only, okay, I know that you're very logical now. I help you how to present your solution process in writing. You help them step by step. You just translate your mind onto a piece of paper. That's all then, to be quite honest with you. Am I right? Are you clear? So that's how you teach. You see, I'm talking about more for pedagogy than just solving a problem here. That's important for the teachers, okay? Yeah. All right, now, I don't want to jump into everyone, but I just go to the, let me see. How about number 4? It's about a fraction. Sorry? Number 4, isn't it? Are you clear about the third one? Question 3, okay, all of you? If not clear, please raise your hand, okay? Don't let me go on. Now, number 4. Capacity of 2 jars are such that half of the capacity of jar A is the same as 2/3 the capacity of jar B. Find the ratio of jar A's capacity to jar B's capacity. Oh, now you find the ratio. No what quantity. How to find? How to find it down? Ratio, the kids will know, oh, I know, teacher, ratio. That means I must be able to find what? Jar A capacity to jar B, am I right? To jar B, right? They will know that. It's equals to what? Something to something, am I right? How to find this ratio? Anybody? Come on. Okay, come, good. Okay. How to find this ratio?
Which
Okay, thank you. Can you all follow this one? Well, so you can divide some more, subdivide the bars, okay? Okay. Interesting, subdivide the bar. I'm not worried about whether the answer is correct, but that's the way that, now, you got two jars in the first place, A and B, yes. Agreed, okay? A and B, yes. What did they say? They said that half, what's that? Where am I now? Half of the capacity of jar A is the same as 2/3 the capacity of jar B. So that means if I have 2 jars here, let me draw some jars, okay? Let's say this is jar A, and I draw it in this way. This is I can draw it, by the way, the bar model, you can also do it vertically, even though it's not very common to see vertical bar, by the way. But ask yourself, if I can draw a bar horizontal, why can I put it vertical? It's the same thing, right? You turn the bar the other way around, become vertical bar, right? Okay, this is my jar A. Let's say I put it into jar A, because the kid can see the jar is supposed to be, a jar is a jar, not like that, it's a jar is like that, okay? So I will show the kids, okay, this is your jar here now. This is my jar A. Now, okay? Jar B, I don't know how tall. But let me draw it. What it says? It says half of the capacity of jar A is the same as what? 2/3 of the capacity of jar B. Half. Okay, this half. About here. Now I know that means jar B 2/3 must be up to here. Am I right? This must be jar B. Am I right? Jar B And 2/3 means what? My one part is 2 parts of the jar B. Am I right? But 2/3 means what? This is only 2/3. I still got another, the third one. Must be of the same size. Am I right? Okay. So that means jar B has a small capacity, jar A has a bigger capacity. They can see that. I purposely draw my bar model in this way here. Now, I take what he's saying. Now you see what happened is I can take my jar and say, okay, I can take this big jar, this one big part here, same as this one here, right? So therefore, this must be also equal to half of this one here. Am I right to say that? Same as what she's doing there. Okay? The only thing that except when she drew this one, she didn't align this one together with it. That means it's, actually this part is the same. Am I right? This part is the same. So when you draw it, it's better to draw it to be the same. So the kids may think that the B has a more capacity. It is not. Actually, B is so if you draw a vertical bar, I can see it. It's the same as what she's been doing there, all right? Now, once I do that, what do you have? Now, can you see the ratio now? The ratio is what? 4 to 3. It's 4 to 3, the other way around. 4 to 3. Now, by the way, this is my bar model, though. I draw it the other way around. Can you draw it this way? You can also. If I can draw it, of course, I can turn it the other way around, fine. But since I want the kid to see a jar to be like that, he never see a jar to be like that, so I just purposely draw it in this manner. So you see, there are many ways to draw the bar model. Okay? Don't be so fixed, it must be exactly this way. No, it can be like that also. This question, you can see that purely on comparing the ratio. That is all it takes. There's no asking about the quantity. Yes?
So the question says the ratio is A is to B. So A must come, then why A is not 4? It should be 3.
What A is not 4? A have 4 parts, right?
4.
What? What is the capacity? Sorry, I said back. Find the ratio of jar B, yeah. A to B, right? Yeah, this A, isn't it? Is this A? A, right? This B, right? So A has 4 parts, right? So B has what? Jar B has 3 parts, am I right? So the ratio is 4 to B? 4 to 3?
But then you're taking the whole thing now. But you're taking the half of A compared to the 2/3.
No. Okay, I think it's a better of the word. Okay, sorry, okay. Capacities, okay, good question that you asked. There's something that I think is a good, in fact, I think when they study about volume, there are 2 words here. Now, these 2 words, what is the units of measurement? Liters, cm cube. Same. But there is a difference. The volume of water in a jar, that's actual volume, how much amount of water in a jar. The capacity of a jar, what does that mean? How much the capacity can hold. How much water can it hold? It's the holding amount. How much can it hold? This jar can hold so much water, in other words. That's the mean of capacity. You follow me? So that is the difference. If you say water in jar A up to here, of course, it's up to here, fair enough. But if you have the capacity, how much can jar hold? It can hold 4 units here. This one can only hold 3 units, in other words. That's the meaning of capacity. You follow me? Yeah, thank you very much. You have raised this question here. Because I think kids always get confused, but they thought they are the same because the trouble is that both had the same units of measurement. Yet the meaning is a bit different. Are you with me? Sometimes I think in teaching mathematics, you also teach about the language itself to the kids, no choice. Because word problem is about language, put it this way. So yeah, I think that, you know, when it comes to volume, capacity, explain these two words carefully to the kids. The meaning is not quite the same. All right?
Then Dr. Lai, what if, okay, what you're telling me is because you say the capacity, the ratio of jar A's capacity 100%
Yeah.
is to the capacity of the B.
B, yes.
That is what it is.
Yeah, how much can it contain?
I want the answer to be 3:4. How would I phrase in your question?
Oh, you want 3 to 4? In that case, okay, very easy. I simply interchange the row of these two jar. I call it jar A, jar B. If you want to, I think that if you want to put it the other way around. Fair enough?
But what I mean is that amount,
Ah.
the half of A capacity is equal to 2/3 of jar
B, yeah.
capacity.
Yeah.
I just only want I don't want the full amount.
Oh, I see. If you want to talk about that. Okay, 2/3, okay. That means you only have this one. You only have one of this. And this one become, if you want to have this one here, it will be 1. No, actually it is a 1. If you have this one here, that's all. That's what it means. So I don't know what you are referring. If you refer to this, so that's the whole reason why I don't know exactly what you are referring to, you see. Because they are the same, because it says it's the same, you know. That means this half of it is the same as this one, right? Same. So it's a 1-to-1 here, right? So it's a bit different. So you ask me the capacity, it's 1-to-1, simple as that. It's no, there's no difference there, see. But you are talking about only half of this A, see this A, half of this A, and this is 2/3 of B. That's all it takes. But the word half and 2/3 have no meaning already. If you don't refer to the whole, you see, when I talk about half the capacity, there must be a whole. Remember, fraction always have a whole. Half means what? I have a whole, but half of it. Parts and whole, okay? 2/3 also part and whole. 2 parts got 3 parts also. So the whole is 3 parts. That's it. So it's a part and whole question here. Okay? Yeah. Capacity does not include about what you put in. There's nothing. It's all empty, you know. Yeah, just a two jar empty, you know. The capacity, that's about all. So I think that's basically what it says. Now, sometimes I think you have questions like this. Then let's say they pour some water inside there and they start transferring some water from jar A to jar B, and then all the ratio will change. Those are the separate ball game altogether, and that type of question there, okay? But this one is nothing, it's just comparing the capacity of the two jars. No liquid, empty jars. That's all there. Okay, well, that's good. Anyway, I think we have a good discussion and see, you know, how the things are clearing up. But what's important is that how to reach out to the kids. That is the most important thing at the end of the day. Okay, I think I want to skip the last one. I think you can go back and figure out the others. They are not so difficult then. And so let's move on. Now to the third type, before and after. Before and after basically is, I have a picture here. You have a situation before any change, but something happened. As a result, the value gets changed. After whatever incidents, anything that happens, it will change. Like, you know, the buses has how many people there? You make a bus stop, 100 people get down, 100 get on the bus there, the number gets changed. So these are kind of a thing that can happen then. Now, this type of a problem can also be solved using the bar model. Of course, the bar model can be a bit more tricky in this case. I think that the before and after in EDUSEED, we introduced it in what grade? Grade 5 is it, or 6? I can't remember. Is it 5 or 6? 6, okay. In Singapore now, I think it has brought the simple before-after word problems to 4, grade 4. So 4, 5, 6. But 4 is a very simple types of before-after model. Very simple. 5, 6 are more challenging. But over here, we still stick to 6. I have not brought it down to 5, and I don't intend to bring it down to 5. Already, the students have been complaining about the 5 and 6 math in EDUSEED. So, okay, so I keep it there first. Okay, until one fine day when they are more ready, then I may make some adjustment. All right, but in the meantime, I just leave it as it is. Now, let's look at some of the questions there. Joanne has 3 times as many stamps as Lena. Later, no, sorry, not Joanne. Jason. Jason has 3 times as many stamps as Lena. Later, Jason gave 46 stamps to Lena. As such, they both had the same number of stamps. How many stamps did Lena have at the end? So this one, both have some stamps, but one person give to another person. So something changed, am I right? There's a change here. Now, how to draw this bar model? Well, my advice is always to draw 2 bar models. Don't draw into one. One before, one after. That's easier. Now, so before, Jason has what? 3 times as many stamps as Lena. That's straightforward. I only have 2 persons, Jason and Lena. So before, that's what they have, right? But later, what happened? Jason gave 46 stamps to Lena such that what? Both had the same number. Oh, same number. Can you see that? You can see that quite easily because to be the same number, that means you move one box down here. Am I right? Same number. That's it. This is a very simple one. So they can see now. One thing the student must realize, in this event, the total number of stamps for the of 2 persons never change. Same number. This is what A give to B and that's all. The total number still remain unchanged. So they can see it that way. Okay? Now I know that since this is so-called, this is 3 times as many, so that these are all have even same quantity, right? So therefore, what I can know that 1 unit is what? 46. Lena at the end has how many? Got 2 units, so it must be what? 46 times 2. Fair enough? So that's very simple. You will see that from the words here, once I draw my bar model, it looks very easy to solve already. Am I right to say that? Now, that's what you let the kid practice, some simple questions first, like this, okay, before you go further. Okay, another one. Ruby had $163 and Laura has $50. Okay, sorry. Okay, good question. Go back. How do I know? No. To have the same, you can only move one box down here to be the same. Am I right? First thing. You agree? Because they're all together four boxes, right? 4 units, so to speak. If Jason gives something to Lena, so that they both have the same, does it mean that you only need to take this one box, pack down here, then it will be the same? Am I right to say that, number one? Forget about the 46, but they are the same, right? How do I know it's 46? Because it says that Jason gave 46 stamps. So where can I put the 46? It can only be here. What? There's no other place to put the 46. What? Am I right to? Huh? That's important. Okay. Huh? Jason give 46. Where does the 46 go? It must go into here. What else can it be? Okay. Yeah, so that's one of the things there in the back. Okay. So be careful when the kids read it. They retreat. Actually, what they can do is if they miss it out, don't worry. Read one more time to see what they have missed out. They can patch it up there still. Yeah. It's a good point, okay? Yeah, let the kids practice so that they will patch it up. Okay, next one is Ruby has $163 and Laura has $50. When the mother gave each them an equal amount of money, same amount of money, Ruby has twice as much money as Laura. How much money did the mother give them each? So we know how much the money give to, we just have to figure out, okay? You give some money, same amount of money to the two kids. Now, how do you draw it? Well, first of all, this one is easy, am I right? This is very easy. Now, the next part is, mother gives some money. How does it look like now? This part, you know how to draw this one, okay? This is straightforward. But how about the second part? When mother gave each one of them the same amount of money. Now, you watch out very closely. I purposely draw it not on the right side, but on the left side. You see what happened. Sometimes in drawing the bar model, you're a bit more creative, but you draw it on the other side. So, same amount, am I right? I purposely draw the drawing is about the same amount. The question is that, how much money did the mother give them each? So, here I put a question mark. Fair enough? Now after giving, what happened? Ruby's money is what? Twice. Listen, twice. So, now, that means this is what? This is 1 unit, this 1 unit. So, 2 units here, 1 unit here. Am I right to say that? So, that is this picture, before and after. I haven't solved it yet, by the way. Of course, I'm going to solve it, yes. So how am I going to solve this question here? Then you know why? How this number come about? Now, think very carefully. This 50 come from here, am I right? Since I cut off here, this also must be 50. You follow me? Since originally this whole thing is 163, so that this one here must be what? 113. Am I right to say that? Okay? You see how the mind reasons, okay? Now, if this is 113, I take this to be 1 unit. Am I right? So this is 1 down. So that means it's 113. This also must be 113. Am I right? Then you can figure this out. 113 minus 50 must be the amount of money what mother gave to both of them each. That is the reasoning part. How to put it in writing? Do I put it in writing? Can you figure out my writing? I'm lazy, I just put down like that. I said question mark plus 50 is equal to 113. You agree? I said question mark plus 50 is the same as this one here. Am I right? This is 1 unit, right? Now if you want to put 1 unit is equal to 113. You will put it that way, fine. And they say question mark plus 50 is 113. Am I right to say that? Yes. So of course I can find the question mark. Are you with me? Come on. Or are you lost? Yes.
Right now is reading the question when it's turned to another alphabetically algebra.
Yes. Actually, this is, okay, bimodal basically is a pre-algebra. Because we have not officially introduced the letters used in algebra yet. But kids can see the question mark, okay, that means it's unknown. But they put X there, they say, what's X? Because they never mix letters with numbers, by the way. You must understand, okay? So we try to delay. You're right. That's why I use a question mark, because they have not learned algebra yet, so I don't want to confuse them. Even though we know what it means. Remember, I said bar model is a pre-algebra. That's the fact of life.
But somehow, in grade 4, suddenly there's a transition from bar model to algebra.
It's all in disguise. You have some, because all along they've been guided, they've been using algebra in disguise, put it this way. We don't want to use algebra because we try not to introduce too many terminology to the kids at that young age. You follow me? So that's the whole reason why. Language is important. For example, in the when they are young, in grade 1, they see a rectangle, they see a square having what? 4 corners. They know corners, corners. They say a rectangle having 4 vertices. Huh? What are vertices to the kids? Hey, seriously speaking. You see, word that we use has to be age appropriate or grade appropriate. That's important. Don't use words that's beyond their understanding. Yeah. I think you asked a good question here. Yes, okay? Be careful. That's one thing that as a teacher, use words that are grade appropriate, age appropriate. They don't understand what you are talking about. Never use words they don't understand. Yes. But of course, when they learn algebra, they say, let x be or something. Okay, fine. But they have not come to that stage yet, so I'd rather talk in this manner. Okay? So, all right, now, you can see that, what I'm trying to share with you is a thought process, how they reason out the thought process. That's what I want to show you. The writing part is a matter of practice. They practice it, then they can do it. Okay? So that's how you see it then. I'll show you a little video here. This actually taken from the YouTube. Somebody have done this one. It's quite some time already. Let me play it. This is a before after.
Hello boys and girls. Today we're going to do a before and after model concept. First, let's take a look at the question. There were 60 more blue ribbons than white ribbons at first. After giving away 3 times as many blue ribbons as white ribbons, there were 10 more white ribbons than blue ribbons left. How many blue ribbons were there at first? Step 1. Let's draw the before model. So there's 60 more blue than white. Step 2. We draw the after model. There were 10 more white than blue. Step 3. This is the important step. We have to identify the change. Yes, 3 times as many blue ribbons as white ribbons were given away. Now, it's usually easier to add than to subtract. Therefore, in this case, I'm going to work backwards, starting from the after model. So what I'll do is, we'll put back 3 units to blue and put back 1 unit to white. After putting this back, remember, there's 60 more blue than white, just like the before model. Okay. What I'm going to do also is now to label them units and the parts. Step 4, we will have to rearrange the white. What we do is try and put the number values together and put the units in front. So blue and white will be 1 part, 1 unit, and a 10. And this is 60. Now, can you identify what to do next? Very good. Can you see that? 2 units is actually 10 plus 60, which is 2 units is equal to 70. Therefore, 1 unit is 35. Now the question is, how many blue ribbons were given away? Looking at the model, we need to look for 3 units. So 105 blue ribbons were given away.
YouTube link here. Okay, you can easily just take a snapshot if you want, and then you can just watch it again. Now this is a before and after. You see how they manipulate the bar model. So far, I think this question I never use it in the EDUSEED, to be honest with you. Okay, but I show you that's what they have been doing in Singapore. So you know how far that the bar model can be used. All right, yeah. Take out the YouTube link there. You can go into there and you can just go through it slowly and understand what is going on there. What's the time now? Let me see. Okay, take a photo, take a shot of the block you. Okay, now let us move on, shall we? No. Okay, here are some of the things here. I want you to try just one question. Just one question. Which one you want to try? Come on, tell me. You tell me which one you want to try. Give me one question. What do you want to try? Tell me, Thomas.
4.
4. Okay. Oh, the last one. Okay. Oh, all of you try 4. Can you? See how it's like. Try number 4. The first 3 you can take it home and they can try by yourself. Okay. Sorry. Don't think about solving it first. First, how to draw the bar model? This is my question. If you can draw the bar model, solving is quite easy. Later they can have coffee later on about later. They come out for a lot about 2:30. I will take a break. So anyone managed to draw the bar model first? Thomas had drawn it? Okay, you put it up there over me. Okay, let's just draw in the bar model first. Don't solve it. See how to draw the bar model. Okay, thank you. Okay, can you all follow? Can you all follow this bar model?
What's the answer?
It doesn't matter what the answer is, but can you follow this picture here in the first place? The approach. I'm more concerned about the approach, not so much of the answer, but the approach. Can you follow this whole approach, the way that's being done up? This one is a bit tricky, I must admit. Because if you draw a before and after model, you try to draw the before, you see that first you don't know what to put down there. Did they tell you about the ratio of these two, red and blue? Am I right? Did they talk about the number of bits, the red bits and the blue bits? They don't know how many. But you know the total is 285, yes. But who has more? I don't know. Maybe there are more red, maybe there are more blue. Totally have no information. So it's hard to draw. That's why when they first started out, he would put out the label, he put out this one, total, but he left it blank. Remember that? That's how I saw that. But the only place that you see I can draw something more meaningful is the after model. Because it tells me there's a ratio of what? 1 to 3. And I love ratio. Once I can say 1 to 3, then I can draw 1 box versus 3 boxes. That is what I can see. So this is the whole idea. Now, you see, in that case, if you want to draw this one, you should go from the what? The way you solve this one is going from the what? After, then you go back to the before. Just like what you watch in the video. Remember just how in the video, the lady also go the other way around. All right? So therefore, you can see in solving problems using the before-after model, sometimes you can go from before model to after model. But sometimes you can go the other way around. You work on the after model, then only go back to the before model. So in this case, what he's saying is that, you know, because I know that whatever left, since he used up what, 45 of the red and 40% of the blue, this is what is left, am I right? So I know that whatever left, this must be what, 60%. This tree must be 60%. All right, 60%. So in other words, if there's 60% here, then this must be what? Now, this 20% is a bit tricky though. This 20% is not 20% of the red. He's just using this to break it down in this manner. That is all it takes. It's a bit different. All right? So that you have to bear in mind that it's not quite the same, you know. This is 20%, but nonetheless it's correct. The 20% referring to, you see, percentage is a, what's the percentage, by the way? Actually, it's a fraction. One of the things that the kid will see, 5% is not a 5. 80% is not a 80. It's 80 upon 100. Like it's 80 upon 100, it's called 80%. 5% is a 5 upon 100. That means the denominator, the whole, is always made of 100 parts. That's how they should see. So once they see that one there, if this is 60%, then this must be what? 20%. Am I right? No, sorry, this must be 40%. So that's basically what it is. Now, so that this percentage is actually referring to the percentage of the blue, not the red. That's important. Are you with me? Okay, fine. After you've seen that now I can see that these 3 units plus this one here, actually, it's all together is what? 825 minus 45. Am I right? It's equal to 240. But the 240 left is not for this one. He must add back the what? These 2 units here. That is what he is doing. Are you with me? Or you are lost? Okay, let me tell you one thing. Okay, if you are lost, don't worry. I like the way that he put it back here. Since I can't figure out anything here, I'd rather restore everything back to the before. So I know that this is 20%, this percent to this one 100% here, okay? So he put down in that manner now. You can see that. Now he's taking this picture back to here. He just reconstruct the before model. So become 20% for this one here, plus 45. That means I put back to 45 there. So I got this one here. This is already, because this 100%, blue is 100%. This one referred to the blue 100%. So that is basically what it is. Now with this one, I can solve my problem using this picture here. You follow me? That's what I'm doing now here. Okay, I will know that therefore it's a what? It is 120% of the blue. 120% of the blue. This is a blue, It's equals to what? 285 minus 45. That is basically what this is. Then from there I can work out how many blues here straight away. Am I right to say that? So that is how. You take this one, you work backward, you will get it there in that manner. So the gist of this question here is that even though at the beginning you cannot draw this one, fair enough, I don't blame you. But from here, I can try to reconstruct my before model using the ratio 1 to 3. Because I know that this is 60%, I have to make 100%, that's why I will have back my 100%, I pack it back, these 2 I put it back here, then okay. Then the 45, I put it back here. I reconstruct the before model so that I can claim back the original 285. Then from that, I work it out. From here, if I take away this number, I will only have 100% plus 20% since they all refer to the blue. So 120% of the blue is the same as what? 285 less 45. That should be the number I'm looking at. This is for the grade 6 question, by the way, okay? Okay, never mind, you can go back and start thinking about it and try to digest it, okay? Because I know that it's a bit, immediately it's hard for you to see what's going on there. You watch the video, go back, go to YouTube there a few more times, then you know what is going on. It's quite similar, by the way. The context is a bit different, but it's quite similar. You work backward from the after model back to the before model as such. So you can see that the bar model can do a lot more things, even questions like this. If you ask me, can you solve it by algebra? Of course. Algebra can handle it very easily, to be quite honest with you, okay? Yeah. But the whole thing about bar model is not just about solving it. It actually helps to develop the students' reasoning power. That's very important. I would rather use a bar model to help to develop the thinking skills, the reasoning power, because that skill which they learn can be used also in algebra later on. That is the whole idea about using the bar model as such, because it's very pictorial. So they will be able to do that one. All right? Now, okay, I'll show you, this is a Singapore PSLE last year's paper, paper 2. We have 2 papers in Singapore. By the way, in Singapore, our primary 5 and 6 or grade 5 and 6 students are allowed to use calculator. Now, the thing is that why we allow, last time we not allowed, by the way. I'm not sure, but Malaysia, do they allow in the government school to use calculator in the primary? Primary, yes or no? No. Yeah. Same Singapore for many years, we never allow students in the primary school to use calculator. Only secondary school, yes, they can use it. But the reason why they want to bring it down to the primary 5 and 6 is because they want to help students to learn to develop the thinking skill. Now, calculation is very mechanical, subtraction, addition, multiplication, and division, right? It takes time. So I say no. We want the kid to spend more time in thinking, in doing reasoning. So why don't we take away those tedious calculations, leave it to the calculator, and let them spend more time into thinking, which is good. But however, we also do not want the student to lose the skill in doing their manual calculation. It's equally important. So as a result, in our examination, there are always 2 papers, paper 1 and paper 2. Paper 1, no calculator. Paper 2, you can use calculator. And as a result, paper 2 questions tend to be what? More thinking questions for them to do in a way. You see that? By the way, IG also doing the same thing now. Paper 1, paper 2, okay? Paper 1, no calculator. Paper 2, yes, you can use calculator. Because we still want to retain the basic manual calculation skill for the students there. All right. Now, this one is paper 2 so that they can use a calculator. Now, look at this. Tina has 96 large and small magnets at first. She gave away 4 small magnets and bought some large magnets. The number of large magnets increased by 50%. She had a total of 114 magnets at the end. We just stop it there. Now, so this is what? Before, after, right? This is an actual PSLE question last year. So I asked, how many magnets did Tina have at the end? Did Tina have more small or large magnets at first? How many more? By the way, you can take a snapshot of your phone if you want to, free to use a phone to take a snapshot of anything. I'm not sure, is it in your handout here? This question? Yeah, okay. So if anything that you like, feel free to use the phone to take a snapshot. All right? Yeah. Now let's see how the student will handle this kind of question. Oh. Okay. Words. Okay, disappear. Okay. Tina has 97 large and small magnets at first. Am I right? Now, which one should be longer? The small or the large? I don't know, to be honest with you. Anyhow, just put something there. So when the kids put a smaller bar for the large and longer bar for the small, it matters not. You follow me? It can be any way, because I don't know anything. But at least I know that the total of these two, big and the large and the small, must be added up to 97. But she gave away what? 4 small magnets and bought in some large magnets. Then the number of the large magnets increased by 50%. And now she has a total of 114 magnets at the end. So, how does it look like? You see, what happened is, I use the same one. This, by the way, what model is this? Park-Ho model. Remember that? This is a Park-Ho model. Not comparison model, Park-Ho model. This one by itself, right? I take a Park-Ho model. He give away 4 small ones, I chop off 4. You follow me? I chop off 4. I buy a more large one, I add 50%. So that this is 50% of what? So that in other words, this is 100%, that means 150%. Am I right? For the last one. So this is how you draw the bar model. And after that, the total is what? 114. Is that clear? Of this bar model. So that's how it is being drawn out. All right? Well, now after I have drawn all these things here, now let's answer. How many large magnets did Tina have in the end? So here's the calculation. After giving away 4 small magnets, total number of magnets, it must be what? 97 minus 4, which is 93. Am I right? Now, if a 93 there, number of large magnets bought how many? We can figure out because now the number has increased to 114. So whatever left, take the subtraction, it must be 21. Am I right to say that? The 21 must be the new one that he has bought. Are you with me? Okay? So that means if 21, that means this must be 21. Am I right to say that? He bought 50%, must be 21. That's what he had bought. If this is 21, 50%, then this must be what? 42. Am I right? 21 times 2 is 42. So 42 is here. Am I right? So 42 is here, 21 is here. So the total number of large magnets must be what? 42 plus 21, 63 altogether. Are you with me? No, I look so puzzled. Are you with me? Okay, please raise a hand. Okay, don't be shy. They say, no, I don't understand. It's okay, don't worry, don't be shy about it. You are here to learn something so you can see what's going on. Okay? So that's basically part A. Now, question is that, did Tina have more small or large magnets at first, at the beginning? And if so, how much more? Now let's see how to answer this second part. Now, in the beginning, now let's see how much do they have. In the beginning, he only has 42 large magnets. Am I right to say that? The 21 is what he add on, so we don't count the L. So at the beginning, he only had this part here. Am I right? This is the beginning. So the beginning is only 42. How about the small one? Since the large is 42, the small one must be what? 97 minus 42, which is 55. Am I right? We know the total is 97 at the beginning. So now you can answer. Does it have more small magnet or more large magnet? Obviously, it's a small, right? So Tina has more what? Small magnet than the large magnet. How many more? 13 more. Fair enough? And that's it. So that is the PSLE question in 2024. Hey, Thomas, is this considered the challenging question for the PSLE last year? No. Oh, so this is not a challenging question. Last year, no challenging. So that means most of the kids can handle these questions. Because in Singapore, it's like this. Once there is a challenging question in our PSLE, or which is a national examination, next day, there'll be lots of parents right in the forum there. My kids come back crying. My kids have a nightmare, blah, 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 all kinds of story. They'll complain. It's too difficult for my kid to answer this question. But actually, the whole issue is that when they cannot answer this question in the PSLE, they will not fail the examination. No, they will never fail that examination. They can still pass with good grades. But the trouble is that either the parents or the kids expect a perfect paper. And that is a kind of expectation of some of the parents, which I think is a bit unrealistic. You actually pressurize the poor kids. Sometimes kids go home, get 95 out of 100, get scolding by the parents. How can you get 95 only? No good, 95. No good. See, sometimes I think as parents, the kids have done their best, 95, well done. Okay, fair enough. Don't pressurize the kids. This is my philosophy. So we are not expecting perfect solution, but we are expecting reasonable performance of the kids. They can do well as a whole. And that's important. Not only in math, in every subject they can do well. I think that is more important. Just being to handle one question there, it doesn't mean anything. Whether it's a math or science or anything, it doesn't matter anything there. But I want you to understand that how bar model is being used to handle this question. Okay? All right. Now, this is the last part, how to teach. Now you know all the techniques, all the mechanics of bar model. How to use it to solve different types of problems there. But now, you actually how to teach. That's what I want to emphasize now. Of course, this is not for the students, this is for you as teachers now here. How do you teach bar model? First, you take a structured approach that helps them to visualize mathematics relationship. The whole idea about mathematics is all about relationship. That's a key word I want to emphasize here. How things are related to each other. Okay? Now, what's the key idea of bar model? Break down a complex problem into smaller or more manageable chunks of information to identify what? Relationships. That's the reason why with the bar. There's so many words there, very complicated. You break it down and some arrange it into a picture. Then they can see relationship of all those entities in the question there. That's the whole idea. And you should demonstrate the structured approach step by step. Like what the step by step. You cannot rush it through. Of course, today I have to rush it through because of time constraint. But in the classroom there, take them through step by step. Okay? And this whole idea about teaching the kids. This is about pedagogy now I'm talking about. The first step, understand the problem. There's always a big issue about understanding the problem. Kids don't really understand the problem. Those who claim that they have no language from which is true, they can read every word, they understand every word in the word problem there. They say, I read through, I understand. That is not understanding. What's understanding? Ask them to read at least twice. Not once. Read to me one time, twice. The first thing. Identify the key information. What is known or what is the given? What's the unknown? Tell me. You tell me. That's important. Okay? Don't rush into it. And then highlight or underline keywords like altogether, left, more, fewer. These are the keywords. Underline it. Or sometimes tell the kids, can you rephrase the question? Say it in your own words. Sometimes they may not understand the words given in the questions there. But now, okay, now you start telling me in your own words, what does it mean to you? Because then you can find out whether or not they truly understand what's in the question. Am I right? They to tell you in their own words. So there's a meaning of restate the problem. They paraphrase it in their own words. Now let's take an example here. Very simple example. Marcus has $24. Carl has 4 times as much money as Marcus. Ken has $18 less than Carl. How much money do they have all together? Now let's see how to do it step by step if you want to teach them. Understand the problem, the first step, right? How to understand the problem? I highlight all the keywords. There are 3 persons here, right? I got what? Marcus, I got Ken, I got Carl. Okay, the 3 names are there. Okay, they all have some money, right? So these have money, $24. Now, 4 times as much as, okay, $18 less. So these are the keywords. Pick up. The others doesn't matter. The question is, right, how much have it all together? These are the keywords. They can put highlight there. They can underline anything which they want to do. It's fine. So that's how you are supposed to teach them step by step to pick up. So, you know, you can see that. I use a color here to show that this is a label, this is a quantity, relationship, and action all together. So that's what it means. Now I put it there. You see, I take a brief note. 3 persons, the name there. Marcus has $24. Carl has 4 times. Is it 4 times? So 4 times Marcus' money. Ken has what? So I will put it down there. Total amount unknown. So take a brief note. No bar model yet. So that is the kind you take them through like slow motion, step by step. Okay? Yeah, you take a shot here, and then I will go on. Okay. Next step, sell the bar model. Okay? Now, once they understand the problem, the next step is to translate the information into a bar model. So, first of all, they must determine what kind of bar model should I draw. Is it a part-whole model? Is it a comparison model? Or is it a before-after model? So they decide which one. Of course, the kids don't know these 3 labels, by the way. But in their mind, they should know there are 3 different types. No matter how they call it, A, B, C, X, Y, Z, doesn't matter whatever they call that. Okay? Then they will draw the bar model. But once you draw a model, please label the box carefully. You know what's given them. Okay. Now, so what they would do is that step 2. Remember, they take notes, right? Remember this one? Now, this information helps them to draw the bar model. Okay, so I will draw the bar model. So something like that. So based on the notes they have taken down, after they have the first step, understand the problem there, they use the key ideas here to draw the bar model. So in other words, you don't ask them to read, then draw straight away. Some can do it, yes, but some cannot. Others, I can't do it, for example. Then I say, okay, go to this one step. You see, this happened only during the learning process. When they first learn to draw the bar model, you go a bit slow. Now, after a while, to be quite honest, all these things, they have draw it on a piece of paper, or it's in the head already. I can read it, I can straight away draw later on. But not at the beginning stage, when they start first learning how to draw the bar model by reading the question. So it's like a slow motion, put it this way. And that's what teaching is all about. Okay? And let's move on now. So they draw the bar model now. Of course, next step, they will do solve it. So they find the equation, and they solve the equation. Of course, they will double check the answer whether it's correct. All right? So this whole idea about third step is quite same as what we've been doing. So they will have to solve it. So once they have it, you can see that the solution is very straightforward. It's very straightforward. They can just straight away draw it, and they will just get it done. Now, the last part here, I do not want to say, problem is solved, I'm happy, and I can just, okay, you know, that's the end of learning. No. I think you should try to reflect and try to generalize it. You want them to reflect on the process and see how the bar model helped them to solve this one. Let them discuss the solution, you know. Let them explain what the bar model represents, the problem, how does it, you know, represent the problem there, how the bar model helps them to find the solution. They can tell you. So let them do it. It's good to stop here and then, okay, you should tell me how you do it. Please explain, you know. So these are ways that they've been learning it. Now, you give them something similar, okay? Provide additional problems that require similar bar models, similar, I say, to reinforce the concept. You change the context, but similar to the one that you have. And then later on, encourage them to generalize it. Show what they might use the bar model in different types of problems, such as those involve multiplication, division, fractions, or whatever that is. Please do. Vary it somehow, but quite some similar. I'll give you some example here. Similar problems. You see that these two problems are different from this one here. But it's similar, the approach, similar. You want to reinforce the whole process of thinking and run a bar model. Because if solve one problem alone is not enough, okay? Reinforce it by giving something similar. So that's basically what it is. Then you can also generalize it. You see that? I generalize it now. It's totally different from this one here. This one I have the fractions involved as such. You can see that. So I changed it totally. So that you can see from one problem, I can extend it further. The whole idea is to reinforce the concepts they have learned, the process they have gone through using the bar model. And I can tell you that once they see something similar in future, they can solve it quite easily. So that is about teaching all about, you know, for the kids as such. Are you with me? Okay, I think today I can end a bit earlier so they can. Oh, by the way, just to tell you that after this one later, I will have a briefing on the update of the IGCSE e-math for the grade 9 and 10. So if those of you who are interested, you may stay back because the IGCSE math, the syllabus has been changed to from 2025 to 2028. It's a different, slightly different from the previous syllabus. So I have already done a review and I have updated all the things there. I will share with you, you know, what the thing has been done for the IG side, because if you are teaching the IG grade 9 and 10, the e-math, by the way, is the e-math, not the additional math yet, the e-math, and you will see that it's a bit different from what you used to see in the past. So if you're interested, you may stay back and see what that is. Now, these are teaching tips. You start with simple problems always. Never start with a difficult one. Don't scare them. You will build the confidence, right? So start, like what shared with you, start with simple and then move on, you know, from simple to a bit more complex, okay? Yeah, involving basic addition, subtraction, all this thing here, before moving on to a complex problem. Use guided practice. Now, that's important. Guided practice, you know what's a guided practice? Guided practice is a question there, and you guide them point by point, like they can fill in the blank. They can fill in the blank. Or you can give them a blank bar model first, then they're going to label the bar model. Put a label there, see what they can do successfully. So these are the guided. That means something is guided there, you know, they fill in the blank, there's a picture, they would just label the picture there, whatever that is. Slowly, step by step. Doesn't matter what grade, maybe in grade 2, 3, 4, 5, doesn't matter. Slowly just, give them the guided practice, okay? And they do it together, as a class before allowing to try on their own. So after that, of course, you will what? Incorporate some hands-on. Hands-on is quite important though, especially for the younger ones. They need the hands-on, okay? I would suggest that if your number is so big, you can use a counter. You know what the chips, those colorful chips, they can play with that one. Use that as a counter to just to do it. Or they can use what we call the interlocking cubes. They can put together. Actually, the cubes put together is almost like a bar model. You put it that way there, right? Now, these are very good hands-on. I don't care whether it's a grade 2, grade 3, or grade 4. They don't feel, I'm so childish to play this thing. Don't worry. There's nothing called childish if you need to use it for learning, to be quite honest. All right, so please use it, okay? Some hands-on, like the blocks, strips of paper, anything represent the bar, okay? But of course, this is only done during the learning process. Eventually, everything must be drawing the model, that's all. It's only learning, they will do paper strip, anything they want to do. But at the end, no more paper strip, just based on drawing alone as such. Follow me? So these are kind of teaching tips that you can use. Promote constant use. Okay? Please use it consistently until it becomes a habit. That's important. The trouble is that kids never practice drawing the bar model. They say, sir, I can do it. Why must I draw? Okay, good. But one fine day he encountered a problem that he cannot solve it. Okay, now you draw a bar model. I don't have the bar model. They never practice. So please, don't worry. Even you can solve it, draw, practice it. It won't hurt you. Okay, you can practice it. Once you come to a difficult problem, at least I know how to draw the bar model. And you look at the last few about the before-after model, that one can be quite creative, am I right? Those kind of bar model, it's not as straightforward unlike the earlier one, like the grade 2, grade 3, that kind of a bar model. It's a bit more challenging. So they must practice drawing the kind of a bar model in order to be able to draw a more creative or more complex bar model later on. See that? That's the reason why, I said that consistent use of the bar model. And one last but not least, when you do bar models, never think algebra. It becomes a hindrance, I guarantee you. Because the trouble is that some of the parents try to help the kids in the bar model, but they think algebra and translate algebra into the bar model, they find great difficulty. Yes, I don't blame them. Now, I'm not saying algebra is no good. In fact, I love algebra. My specialty is algebra, just to share with you. But over in the bar model, I'm telling you, don't think algebra. Okay? Think visually. See pictures, that's important. So, in other words, I'm trying to talk about is to apply visual learning. How to apply visual learning, mathematics. Actually, visual learning is a very effective way of learning, not only for math, even for science. Okay, right now I'm looking at the IG Pure Sciences. I put in lots of visual skill there, okay, how to apply visual skill in doing science. Especially some of the science topic is a bit abstract, how to visualize it. So these are kind of a thing that we are looking at it then. Now, actually, this bar model workshop comes hand in hand with another one. It is called problem-solving strategies in primary mathematics. There's another workshop. Of course, today I can't do it together. And this workshop, basically now you have learned the bar model. Bar model is only one of the many strategies. It's not the only one. There are many other strategies here, all right? So I will talk about the wide spectrum of strategies in solving a variety of math problems. Rates, ratio, speed, you name it, anything. Geometry, anything, all right? So, and I will talk about the Poyas method. Are you familiar with the Poyas method? The 4 steps, the Poyas method? Sounds very simple, sounds like common sense. Sometimes common sense is not that common. No, common sense, no, not that common. So, how to use it effectively? The trouble is that kids always skip the 4 steps. They find shortcut here and there. No. The 4 step, in a way, is a very good to help them to work through it consistently. All right? So you will learn different types of strategies, and then how to teach the kids to apply the strategies consistently in the student process. So this is another workshop. Maybe another day I will ask Chung to arrange it, and then we can do it together for all of you. These two usually go hand in hand. Because bar model is only one of them, but once you can learn these two workshops here already, I think you are very well equipped to handle practically all the primary math problems already. Yeah, there's no exception to it. You have any question? Feel free to ask me. Yes.
I did have one question because my class I'm handling for grade 6 to grade 8.
Yes.
So just now I say that bar model is suitable for students from grade 1 to grade 6, right?
Yes.
So although I'm teaching grade 6, should I encourage them to use bar model or better transition to algebra?
It depends, but
Also one more context is that these people, they never learn bar model before.
if they have not, that means they've transferred from another school, most likely, yeah? If that were the case, then probably I may not want to insist the use of the bar model. Fair enough. Okay, I'm not against the algebra, they can, but those who are coming up, you see, bar model actually have to do lots of thinking, lots of reasoning skill. Algebra doesn't have that much to be called, it doesn't mechanically just do it as such then. Okay, these are the exceptions. But, fair enough, I think I understand where you are coming from. But those, if they come at a lower grade, like grade 4 or grade 5, I would say they will go to a so-called crash course in bar model, which it can be done quite easily for the students there. So another 6 hours or whatever it is, for them separate into several sessions there, master the basic, they should be to draw the bar model. By the way, if you don't mind, I'll show you one question. This one is actually a bit different from this year's our PSLE, which is our national examination for the grade 6, or what we call the primary 6 in Singapore. This is a question, which is not in the notes. You can take a picture if you want to. Well, it looks like this is a geometry question, is it, or shape problem. It said that the figure consists of 3 identical overlapping equilateral triangles. Find the length of AB. This is the length of AB. And you see the overlap. They give you all the measurements here. How to find the length of AB? Now, first of all, the kids must understand the properties of what? Equilateral triangle. Fair enough? The 3 sides are equal. The 3 angles are equal, 60 degrees. Fair enough. They learn all this. Okay, so these are what they need to do. And that's what it takes to handle this question here. But the trouble is that all these triangles, they're the same size, same shape, but they overlap. One thing about math, if things overlap, you tend to complicate the matters for the kids. Am I right to say that? I don't care whether it's a triangle or square or rectangle. Once they overlap, the kid, I don't see anymore. Something is hidden somewhere, am I right? So, now this is our primary 6 question. This year, 2025, okay, just over, I think that was in, when was it taken? I think in October, isn't it? October time frame. Yeah, October. Our PSLE is only for about 2 weeks, all over already, okay? So they do this one. Now, how to solve this problem? Of course, there are many ways to solve this problem. I'm not saying the only way. I'm going to ask you one question, now you think about it. Can you use the bar model to solve this problem? Come on. Hey. Now, this is not a problem. This is a geometry. I say, can you use a bar model to solve this problem? I'm asking you this question. And if so, what kind of a bar model can you use to solve it? You got 3 types: part whole, comparison, before after. Which one is suitable for this problem if you want to solve this geometry problem here? Now, come on, you can start thinking about it and start drawing it, whatever that you want. Feel free to do so. Come on, this is my last challenge to all of you. Start cracking your mind before you go off or anything. How would you do it? how to draw bar model for this one. My goodness sake, how to draw bar model? You can discuss, by the way. You can have friends and talk to each other and say, hey, how to draw it? Please do. First step is understand the problem. Anybody want to think how to do it? Don't know where to start. There, you got it. Bar model, no bar model. By the way, it can be solved without using a bar model though. Yes, I agree with you. But kids, when things overlapping, it's a bit hard to see. You know why I said bar model? Because bar model makes it very clear how to solve it later on. Can you think of anything? Okay, don't worry. All right, okay. Never mind, I'll show you what it is mean by using the bar model. So how to use bar model to solve this problem? It seems that bar model is used to solve word problems, right? But never do you use it to solve a geometry problem as such. But lo and behold, I look at it. The trouble is that I only want to know this length now. This length is same as this length, right? Same length, right? The trouble is they all overlap. How can I use the bar model to handle it? I take this whole length. I write down what I know. What I don't know, I put question mark. Is it easier? This is a what? This is a Park-Ho model. Park-Ho. Those I know, okay, good. I put in the yellow color. 18, I know. 3, I know. But the blue one, I don't know. But that makes it very clear, am I right? I take the whole thing and break it into chunks. These are, you see, the good thing about it, these are not overlapping anymore, am I right? The length are different. This length, now, this Park-Ho, the parts are not the same length though. Some longer, some shorter, fair enough. So these are not equal parts. So if only I can find all these unknown parts, I'm okay. Am I right to say that? Now, so from here, I'm going to see how to solve it. These are the grade 6 students. They have learned to write equations, by the way. So I'm using equations to solve it. Since these are equilateral triangles and all the 3 of them are identical, I know that this length must be the same as what? Which length? This length, am I right? This length, same as this length, am I right? If this length is the same as this length, that means what? 18 plus 1 question mark is the same as what? Question mark plus double question mark plus 3, am I right? That is my first equation. So I will do it that way. Am I right? Am I right? Now, once I see that, one thing about they have learned, if something in common yet the sum is the same, then I know that these 2 must be equal, am I right? 18 must be equal to double question mark plus 3, am I right? I can see it. Straight away, I can find this length, which is 15. Oh, I know this length already. Very well. What else can I do? I must find this length now. I know one thing. This length plus 3 plus this triple question mark is 41. Am I right to say that? Since I know that this one is 15, I will know that 15 plus 3 triple question mark is 41. I can solve this length here, which is 23. Are you with me? If it is 23, That answers out. I know that therefore this length must be what? 23 plus 3 is what? 26. But this length is the same as that length there, equilateral triangle, and the three of them are identical. So my answer is what? 26. You see that the bar model helped me to visualize all the length, all the overlapping length here and there. Because I'm breaking down into very non-overlapping here. You see that? And I use equation to solve it. So this is basically is algebra in disguise. Bar model is pre-algebra. I mentioned that. Is it easier to solve if they would draw a bar model, something like that, and they'll find out, and they can solve it. And this is this year's our primary 6 questions. Now you see that bar model can extend to solve something which is not word problems here. I tried it, hey, it works. So you may try some of the geometry question next time. See the bar model can help to solve it for the primary kids. I think they will, hey, good, I can use it to solve other types of problem there. Never before. We were so used to solving it for the word problem, but never before we use it on this question on geometry shapes.
This is not considered a challenging question.
Not challenging. Semi-challenging for the kids. Some of them are considered difficult. Because once they're overlapping, they get very confused.
This is like similar to the substitutions method in the algebra, right?
What's that?
This is similar to the substitution method in the
Yeah, correct, in a way. So you're right. You see, once they learn all these things here, when they go into algebra, it's a lot easier already. Am I right to say that? Yes. But it's just that we don't want to use the X, Y, Z, they get very confused. But I don't know what letter stands for what, you know what I mean? Question mark, they understand very well. So that's the whole reason why.
How do we apportion the 2 question mark? You see,
No, because
2 question mark seems like smaller than 1 question mark.
one question mark.
Doesn't matter.
X, Y, Z lah. Instead of X, Y, Z, I say question mark, double question mark, triple question mark. That's all, you know. Yeah. It's actually, as I say, it's an algebra in disguise for the kids. But since they know how to handle this kind of a thing, they know how to handle question mark, they know how to handle X, Y, Z here, so okay, I'll give them this one here. But the whole issue is also the question mark. The whole issue is that part-whole model makes it very clear because it makes all the overlapping not overlapping anymore. Am I right? So that's the whole idea about using it. But by the way, this is not the only way to solve it. I guarantee you there are many other ways to solve it. But I just happened to sit down and work on it and I find, hey, I can use bar model to handle it easily by finding all the unknown parts. Of course, I used equation to solve it. Yes, you're right. So that's the end of it. The whole idea, basically, a bar model is how to make something complicated easier to understand. That's all I'm doing it. Is to simplify what is not clear. Because it's not clear, right? Or it's not clear. I try to make it clear by drawing the bar there. So that's all I'm doing, and nothing else to it. You see that? So I will use this one, then start thinking about comparing length. Oh, this is the same as this one. Because we know all these lengths they are the same, all right? So the same as each other. So that you will know that, there are quite a few equations that you can form by looking at it. All right, so okay, I think that's the end of the day. I will stop here, take a short break. If those who want to stay back, I think I can study in about half an hour's time. Okay, I'll come back here if you want to stay back, and then I will do the e-math update. Okay, thank you very much for your time, and I hope that you learned something here. Okay, nice meeting you all. Yeah. If you have a question, feel free to ask me, okay, now? Yeah, anytime you can ask me.
I have a question I want to ask you. Because after 30 minutes, you're going to start to tell us about the updates for the grade 9, grade 10, and GCSE, right? But I think it's that I need to leave now already.
Okay. I don't know whether they will videotape, I think.
Just
No,
a video take lah.
I think they will then you can watch a video lah if you want.
Can you send it to me? Or
No. I don't know. You have to log in. I don't know. You can ask them. I don't know about this. They will arrange it. EDUSEEDS will arrange how to use for you to view later on then. All right. Check with the office and see if you want to view it. Check with the office, then they will know. Chung should know how to talk to Chung there. Okay. Yeah. Okay.
One question I want to ask you. Some author in Singapore, they like to use this kind of approach in learning math. They start with a question, then they give the question, form the student in group, they ask them to solve, then finally they have the structure, the reflection. They call it inquiry-based learning.
Yeah. They
It's
can,
totally different from what you...
no. I'm only doing the technique. Actually, you can also use that in the inquiry base if you want to. Make it into a small little group, they can discuss among themselves also can. You give a question, right? They can discuss how to run a bar model. You don't discuss how to run a bar model, it's fine. Yeah. You follow me?
Yeah, follow.
That one got to do with the pedagogy in the sense that it's a matter of how your class going to carry your instruction there. That's what we call the student-centered learning environment. That environment, I'm trying to promote that environment in EDUSEEDS next time.
I see.
Okay? And as a teacher now, you will teach less. But you facilitate the learning. You go around, guide them, facilitate the learning. This is called the student learning environment.
Quite time-consuming, actually.
Hey, but they learn a lot faster. Singapore been doing that already. No, you still talk about it. You want this one back then? Sorry.
After this, have finish already.
This one finished already. Next time, I don't know when the video, the second one's on IG update. No, what I'm saying is that extra. Take it back. Okay, I'm going to start my second session. Come on, okay, back.
I take picture with you?
Okay, no problem, sure. Why not?
Yeah.
Come on, come on. What do you take? Come here. Come. Why?
Oh,
hey,
we'll take one first, yeah.
Why so troublesome? What's that? Take one.
I haven't really take one.
I'll give thanks to you, Lord, and sing praise to your name, O Most High. I'll declare your love in the morning and your faithfulness by night. For you, oh Lord, have made me glad. I will sing for joy at the works of your hand and
Shall we?
rejoice.
This is a brief update only. It's not a long one, about half an hour. No handout, it's just a briefing so that you know what is happening. For those of you who are using the EDUSEED eMath, so I've done about for the past 1 year trying to update it according to the latest IGCSE eMath syllabus, the 0580 syllabus. This one will be used for 2025 to 2028, if I'm not mistaken, okay? So I will give you a brief update of what has been done to the material. Now what you see there, basically, most of the changes made are in the PowerPoint because these are the teaching slides. So of course, once they've been changed, some of the questions may be changed accordingly. So the question will go according to what has been changed in the PowerPoint slides there, in the activity book, in the so-called this MT and this module test, and also the alternative test and all the things. Okay. Now, just very briefly, just to tell you, this is basically the syllabus which I'm talking about. It's from 2025 to 2027, 3 years. So they've been talking about. Now the focus now is more on the conceptual understanding and problem solving. Problem solving is always there for the IG. Yeah. Now, the assessment basically is about the same as before, except that now in the paper 1 and paper 2 for both the core and the standards. Okay, and paper 1 for the core is that there's no calculator. Paper 3 has calculator. Similarly for the standard, paper 2 has no calculator, and paper 4 has calculator. So that's basically what they've been doing then. Okay, you can, by the way, you can get out of this syllabus and go through it, all the details. I just highlight, what are the things that has happened in this latest syllabus. Now, about the assessment objective, basically they have, we are talking about the assessment based on the so-called the AO1 and the AO2, basically the knowledge understanding of mathematical techniques and analyze, interpret, and communicate mathematically. This is the second objective, and there's a weightage they've been giving there. You see the weighting to add 100%. And you can see how these 4 papers, 1, 2, 3, 4, for the core and extended, are being distributed by the assessment objectives so that you can see what's going on there. And yeah, just very briefly, just to tell you that how they assign the weighting for the assessments. Then you know which one is more important than the others as such. Now, about the contents, what has been added, what has been removed. Okay, first of all, for the core, I'm taking the core. Inequalities are added. Previously, there was no inequalities, not inequalities. Now they also recall the square roots, cube roots, and other powers of the roots. This one used to be in the extended syllabus, but now they bring to the core. Okay, so for the extended, this is no difference there. What's been removed? Vectors gone, no more vectors. Okay, no vectors, and also they say no data collection, but it can be taught but not accessed. You can teach it, but not accessed. That means the examination will not ask you. Okay, so that's basically what it is. One thing about that is that now they provide the formula sheets for all the papers. So kids don't memorize all the formulas. It's given to them then. So that's basically what you'll be seeing. For the extended, certs come in. Because they remove the certs from the additional math. And they bring it down to the extended syllabus. But then the thing is that when they bring it down, it's very much simplified. So that means the lesser things now in the certs, you can look at it, okay? But domain and range comes in finally. Previously, they don't talk about domain and range. I think that's good. Domain and range of functions, they will bring it there. About the exponential, this is about ax to the power n. This time now, they will have the fractions, plus or minus half, for example. They will bring it in there. All right? So, and the exact trigonometric values, students need to commit them to memory. Now that's important. So they have to remember all the special triangles, all the angles, and all the things there, and especially their trigonometric ratios. So don't forget, that's important. Now what has been removed? For set theory, no more proper subsets. Gone. Okay? No linear programming. Gone. The funny thing is that they also remove the congruence criteria. Remember the congruence triangle for the triangles? They remove it, but knowledge of congruence still remain. That's important. Doesn't mean they throw away the concept of congruence. It's still there, except that they will not access it on the congruence criteria of triangles. You know what I mean, okay? So that's basically what it is. Again, same as the data collection, not examinable, but it can be taught. They also remove the box and whisker plots. So a lot have been simplified, to be quite honest with you, okay? And again, they will provide the formula sheets. Now, that is in the syllabus. However, in EDUSEED, we may not do exactly as what they've been doing. Because I think some of the things they said to be excluded, they are quite good. We should not exclude them totally as such then, okay? So therefore, some of the things we retain, some of the things we remove. Now, in terms of the contents, all the missing topics we will incorporate. Whatever is not there, we'll incorporate them. That's a fact. Certs have been incorporated, so we know the certs will be inside there. Now, what have been excluded by the syllabus, the topics excluded by the syllabus, and which are not very essential, we also remove them. For example, we have removed linear programming. No more. So a few things we will remove it, okay? But some of the excluded topics by the syllabus, which we deem as useful, retain them. For example, box and biscuit we retain. We don't throw away everything. It's a good thing. What should we throw away then? All right? So some of the things they would do. So it's okay. It's no harm for the kid to learn a bit more. Put it this way. And it's not that difficult to learn the box and biscuit and plus a few other things. Data handling also is there, even though it's not examinable. Since they say you can still teach them, and we will keep it there as such. So these are kind of a thing in terms of the content. Now, in terms of the pedagogy, now there's something which in the past it have never been built inside there. But this time around, I weave in some of the pedagogical approach. In the past, we only present you with the contents and show you examples, how to solve problems, so on and so forth. Maybe a few cautions in there, watch out for this and that, so on and so forth. But this time around, I weave in the pedagogical approach here for two reasons. Number one is for the teachers. Because we realize that some teachers may need to know how to approach a certain concept, whatever that is. We have some pointers, tell the teacher that's how it should be approached, number one. Also, it's good for the student to learn. When they learn, they see how the thing is supposed to flow through. Okay, so that's basically what we'll be doing then, yeah. Now, we try to engage right in a conversational and narrative style. We enhance it further. That means the way we write is as if we are talking to the students or talking to the teachers, like personal, okay? What do you think, for example? Do you see this and that? So these are the kind of a conversational style. And we're going to narrate a storyline. So something, is more personal, try to engage the students as far as possible. We also have to rearrange some of the topics in a more logical order. I look at the previous one, I say, hey, certain topics should come first before the others. So that's important. So we do some minor rearrangement. Of course, there are reasons why we do it. I will explain to you some of the things why we do it in that manner. Okay? Now, some of the key features we want to make aware to both the teachers and the students by prompting a question. Prompt them, what do you see? What do you understand? So we prompt them in that manner. We try to unpack important concepts. Some concept is so important, we try to unpack it, make it clearer to the students or to the teachers. And we use analogy now. That's one of the things. Teaching using analogy is more effective than just giving the plain facts as such. Okay? And some of the concept, we try to elucidate the meaning of the concept clearer to the students or to the teachers, what it means. Some of the important concepts we try to elucidate. Now, give you some example. What do you mean by all these points about the pedagogical approach? First of all, look at this one here. We try to rearrange some of the lessons in a pedagogically logical order. For example, this is on the second module, solving quadratic equations. Previously, it was like that. We started with the graphical method, followed by factorization, followed by completing the square quadratic equation. Now, what I have done is that I switch these two. I start with factorization, then followed by the graphical method. Now, why I switch it in that way? It's not arbitrary, though, by the way. There's a reason. Because this is a grade 9, right? In grade 8, the kids learn what? Factorization. Don't forget. So since they learn in grade 8, why not we carry on with the get concept of factorization to solve quadratic equation? That's why I put it at the first one. You follow me? Something they're already familiar with. It's just that now I switch it around so they can recall what they have learned in grade 8 and they can use it in grade 9 using factorization to solve quadratic equation. That's why I put it first. That's the reason. Now, of course, followed by the graphical method. These are very pictorial, which is good. I need this one. Why? Because I need this one for 3 and 4. Completed square and quadratic formula will need a picture which they have used it in the graphical method. That's why I put it in the second, followed by these two other methods, completing the square and quadratic formula. So you can see that I rearrange the order of the lessons in this manner. These are very minor, not a big issue here, okay? So, and that's what I've been doing. Now, I try to enhance the conceptual accuracy. In other words, some of the things there which I think it should be better presented rather than what it is. Take for example, this is about fractional indices. So we try to introduce what do you mean by 3 to the power 1/2. Okay, so we said, okay, and we apply the product rule and we get it. Now, by the way, this one unfortunately appeared in too many textbooks, whether in Malaysia or Singapore. Actually, you can't use the product rule. Why? Because the product rule that they have learned is a product rule for integer exponents or indices, not for fractional indices. In other words, if this is a 3 to the power 2 times 3 to the power 5, yes, they can add the 2 and 5 because they learned that, product rule of integer indices, but not fractional. So therefore, in the case of the fractional, what they need is that what they have to. So that's the reason why I have to change this one here. So that's why I change it to this way. Now, of course, followed by exercise, fine. Okay, nothing wrong with it. Nothing wrong with that one. It's just the way you introduce it. Okay, now similar for this one here. I change this field here. I keep the example, by the way. I keep the example here. You have to introduce this definition. A to the power 1 over n is equal to the nth root of a. That is the definition. You don't derive this one. This one is given you, FOC. So once you have that, then we can talk about what does it mean to be 3 to the power half. In other words, 3 to the power half means what? Square root 3. 8 to the power 1/3 is a cube root of 8, so on and so forth. Because we introduced this definition. So it's a matter of definition, number one, the first thing. And once they know that, then I can start talking about multiplying altogether as such. So what does it mean by, 3 1/2 squared is equal to 3? Because I know that 3 to the power 1/2 is what? Square root 3. So I'm going to write this as a square root 3. You see that? 3 to half times 3 to half is square root 3 times square root 3 is equal to 3. That's how you get the 3. It's not by adding the half and half equal to 1. No. It's by multiplying the square root to get the 3. You follow me? So that's basically how you get the 3 there. And similarly, x to the power 1 over 5. To the power 5, you do it 5 times. Again, you turn it to the 5th root and you do it 5 times, you get an x. So because of that, then by induction, a, 1 over n to the power n is equal to a. And now we have this already. So once we have that, by induction, we can have it in this manner. You follow me? So that's the whole idea about how you introduce a concept from a definition. Because you can't really use the power rule for the integer indices. Then, of course, followed by the example, as what you see before. Now how about there's another second definition there. Because now there's 1 over n, right? But how about if I have a to the power n over m? I have to define in this manner. So that's a definition. So there are two definitions, the first one and the second one. By the way, you're free to take the snapshot if you want to. If you don't do that, you can still see that in the PowerPoint next time, I think when they roll in January. So for example, if you want to evaluate 27 to the power of 2/3, now use definition and you just how you would do it step by step. Because I use definition, so this is 27 squared, okay, I work on it. This becomes a cube root, I work it out, I get a 9. So that's how you handle it, using the definition. So this is a more precise way of presenting the concept of the fractional power. Now we talk about product rule. You see, at first we have product rule for the integer indices. Now we have the product rule of fractional indices. That means now when the same base, both are having the fractional indices, I can add them together now. And I say that there's a proof for it, by the way, but I said we omit the proof here. It can be proven. Okay, so I leave it there first. I'm not going to prove it. I just want the student to know that it's a statement, you have to prove it, but that's the end result. You don't get that one from the power rule of integer indices, no. You have to do it separately as such. But since I said omit it, you just take the result as is, and you can use it as such. So once I give you this rule here, then only you can use it. You follow me? However, if in your class you got some smart Alex, they say, teacher, can I prove this one? Sure, be my guest. They go and prove it themselves. By the way, it's not difficult though. They can prove it. They can see that why that is equal to that. Using what? Using the earlier definitions. I have the two definitions there. They can establish this one quite easily to share with you. But now I just omit it for the meantime. You follow me? So therefore, I have to establish the product rule of fractional indices before they can use it. Because it's not the same as the one you have earlier on for the integer indices. So I enhance it. So similarly, I will have the fractional index rule similarly here. So you can see that, you know, the approach using it, we go by definition, we go by the product rule for the fractional indices as such. Follow me? Okay, so to let you know what the changes make. Anyway, don't worry. I think when you start teaching your grade 9 students there, you go through it yourself one more time to get a good understanding what is happening, you know, in all these changes. Now, second one, I think we talk about emphasizing the key features of concepts by prompting. It's good to prompt them. Now, example. This is one activity, I think, from the so-called from the PowerPoint, you can see that, you know, they're supposed to learn what? They're supposed to show that these two angles, you know, is subtended by the same arc are equal, right? So they learn this property here. Okay, fair enough. So they get them have hands-on. It's a good activity, by the way. Okay, now that's the property here. Angles at the circumference subtended by the same arc are equal. Good. That's correct. So we have that. Okay, fair enough. Then we come to example straight away. Now I want to emphasize that property. Angle on the circumference subtended by the same arc, you know, or same arc are equal. I want to emphasize this point here. So what I do is that I do the same thing here. By the way, I didn't change activity. Same activity here, no change. I keep it, okay. Same property 1, no change for this one, but I add this example. Which of the figures shown do not satisfy property 1? You can pick up quite easily, right? Can you pick up quite easily? Very easy. You can say, okay, the first one is not, right? This is not, yes, no. Fair enough. But that's not good enough. What are the two key features of property 1 now? What are the two key features? Please tell me. You're a kid. Okay, good. You understand? Can you tell me what are the two key features? What are they? Come on. Come on. Same segment or same arc, right? First thing. Another what? The two angles must be at the circumference. These are the two key points they have to remember. You see, you have to emphasize what is the key point in the property. So I add in this one here to be more aware of, oh yeah, huh? Else they will say that they are equal, or they will say that they are also equal, or this they are also equal, because the kids sometimes they are very careless, you know. So they emphasize. They must be subtended by the same arc, and the two angles must be on the circumference. Then only they can be equal. Okay, these are two properties. You have to stress it. So these are some of the touching points, you know, I add in here, you know, for you to do now. I try to unpack some important concept. That's one very important concept. I'm sure you know this one here. Yeah? This is like a bit like magic. Don't know what is that. X is equal to minus b plus or minus squared or b squared minus 4ac over 2a. My goodness, it remembers by heart, but what does it mean? Okay? I'm trying to unpack this formula here. What does it mean? All those very mysterious numbers thing inside there. So I'm trying to, because see, this formula encapsulate, it covers a lot of good information inside there, which I think we're going to unpack it to see, hey, what's inside this formula here, okay? So that's what I've done. Unpack means what? Pack something together into smaller self-contained. So you can't see it, I unpack it. So that's the meaning of encapsulate, okay? Now I go the other way around. Now they can see the formula. Oh, now I see what that is. Plus or minus this one is the what? It's the distance from the line of symmetry to the two roots. They see it immediately. That's good. And they can see these two are the intercepts. Okay? And we call a name, this is called the discriminants, by the way. They know that. This is a name label given to this. So that now the important thing is to see this one here. Separate them. Okay? Now what is this minus b over 2a? Hey, that basically is the equation of the what? It's a line of symmetry. You see, everything has a meaning. So this is a line of symmetry, and you have a distance to the two roots. Here's the distance from the line of symmetry to the two roots, one on the left, one on the right. Now, this formula now makes better sense. Am I right to say that? There's meaning in it already. So that's why I'm trying to unpack it. You will find that, by the way, in the PowerPoint there. Okay? And by the way, in the syllabus, they introduced two different forms of the quadratic functions. Now, you know general form, right? This is a general form they have been so used to all the time. But now they also introduce two more forms called the intercept form and the vertex form. So in other words, students must know how to convert from a general form to the intercept form or to the vertex form, and vice versa, the other way around also. So they are got to get three forms: general form, intercept form, vertex form. Now what are they? That's the intercept form. So in other words, they can write a general form, okay, into this form, and that's how they will do it. How they do it? I can do it by factorization, for example. So what they can see immediately, these P and Q are the what? Are the roots. Am I right? These are the roots. This is where the graph cuts the x-axis, or they call the x-intercepts, for that very matter. So they can see it there. All right? And they can convert easily by factorization, as I said before. So that's one way. But of course, going back is quite easy. They expand it, they get it back there straight away. Am I right to say that? So for intercept form, going back to general form is very easy. Just by expansion, and they can get it back. So here's some more example here and there, so I don't need to go through it. Now, usually you do it by expansion, right? And I say that there's an alternative method to the above solution. I show the next slide. Now, what's the alternative solution? Look at it. You can take the roots. Okay? These two are the roots. So therefore, the coefficient of A is nothing but the what? The sum of the two roots. You follow me? So AX, of course, is the same, and AX squared is the same, minus, A times P plus Q. And the last one is the product of the two roots, and you plug inside there. So in that case, you see what happened is that I take this one here, okay, and here you throw a minus sign by the other way. You add the two roots, product of the two roots, you simplify it, and you get it immediately. So that's how you were to do it. So therefore, they will see the B in the middle is nothing but a sum of roots, and the constant C is nothing but the product of the roots there. of course, you divide by a, so that you will get a monic function, by the way. That means the coefficient of x squared is 1. So that's how you do it then. So that will help them to be able to do a very fast, by looking at the roots, to write down the general form of the quadratic functions as such. Are you with me? Okay? Okay, never mind. Once you see the PowerPoint, you just digest it slowly. If you, okay? Yeah, so I'll give you one example here. You can see I pick up the roots there, I can do it down. So this is another way of doing it. Okay, the vertex form. Now, there's a vertex form here. Vertex form is quite good because straight away they can see, you know, where is the line of symmetry. Okay, where's the line of symmetry? To be quite honest, they can see it very well there. They can straight pick up the minimum point or the maximum point. From there, straight away they read minimum point, maximum points. Okay, they can expand this one here and then get back your vertex form. Am I right? Of course. Okay, you can expand this one and you get back your general form. Fair enough. Everything by expansion, you can always get back to the general form. But how about from a general form to the vertex form? You always do it by completing the square. Am I right? Hello? Correct or not? You will do by completing the square. You should be able to get out, you know, the vertex, which is h and k. Okay, so that is a way you will do it then by completing the square. But I'm sharing with you, that's another way of doing it. Remember, this is a vertex formula. This is a vertex formula, don't forget. What's the vertex? It's where the line of symmetry passes through. Am I right? Remember about the line of symmetry? Okay, let's draw a picture here. This is a line of symmetry, okay? That line of symmetry basically is what you have. This is line of symmetry here, okay? And here's the vertex. You see that? Are you with me? So that's basically what it is. So that is basically what it's a vertex formula using this one here. And this one is what? X is equals to minus b over 2a, which is, you get it from the quadratic formula there just now when I wrote it down. Remember the quadratic formula? Okay, remember that? Yeah, when I wrote down this one here. Remember that? And you pass through the vertex. It could be minimum point, or it's this way, it's a maximum point. So that's basically what it is. And therefore, you can use this one, and you can plug inside there, and straight away, you can expand this one, and you can get it the vertex very quickly in this manner. You see the A, B is there, so I can use my A, B, and everything, and plug inside there. Now, this one you got to evaluate to get just to get it there. So that's how you would do it then, all right? So this is an alternate method to use the vertex form as such. Then you can get all this information right, from the vertex form as such. So these are the things which have been added to the PowerPoint. So I give you a different formula now. That's the formula for the vertex form. Y is equal to A times X plus B over 2A minus D. What is D? D is a what? Discriminant over 4A. So that is a way allow you to straight away write down your vertex form without having to complete the square. So the kids only need to know this formula here, and they can straight away write it down without having the trouble going through the process of completing the square. Follow me? Okay, never mind, as I say, since I'm rushing it through, so you may have a problem trying to understand it, but it's okay. Just get some idea first. What are the changes made to it? So that's how I unpack the quadratic formula as such. So I show some example now. Of course, once I've done it, I'm going to show you how to use this formula to find the vertex, to find the vertex form of the quadratic function as such. Okay, you can see that these are some of the questions which I've added in there. I won't go through it anymore. Now, so these are, now after that, I will have one exercise there, and you can let the student practice all those things there, because they're very new to the kids there. So I think in the classroom, you can use, okay, let's practice all these things here, after they have learned from you about the two different forms, intercept form and the vertex form, or the quadratic functions as such. So these are the changes which I have made then to it. Now, I also employ analogy. What do I mean employ analogy? Now, this one is on statistics. You see this whole topic about statistics, we say that data provide valuable information. Am I right? Okay, we talk about how people are using the data in business world, used by engineers and whoever they are, do that kind of all sorts of calculation there. But we say that data per se are too raw to be meaningful. So they need to be processed, what? To extract useful information. Fair enough. We all know that. Data are too raw. But to the kids, what does it mean? It's too raw, it's meaningless, but we will process it in order to get something meaningful out of it. So why don't we, instead of telling you about this one, why don't we use it something easy to understand? Now, of course, followed by, now straight away in your original one, after that slide there, it will follow by the exercise immediately, like the first example, as such, they will do it. But in my case, I make it easier to understand the difference between the data and information. Everybody loves cakes, all right? They all love this cake here, chocolate cakes. But how to get chocolate cake? You need all the ingredients. You have to mix together, process it, am I right? In order to produce a tasty chocolate cake. These are the data. This is the information. Is it easy to understand? They all love to eat cakes. So in other words, now we teach using analogy. Help to understand, oh, what's the meaning of data? What's the meaning of information? So I brought analogy here. You see that? So I say that the data are the ingredients. Information, the finished product, in that case, is the cake. So that's what I try to do. So you can use this kind of analogy to teach the kids to understand the difference between data and information. And after that, and I talk about how to handle data. So there are different ways of handling the data. Okay, so these are the way how to collect the data. We have survey, interview, blah, 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 so on and so forth. We collect the data here. And how do we organize it? With all these, bar charts, frequency table, stem and leaf and everything there to organize it. And last but not least, we can generate statistics. And so far, I think for the secondary, they only talk about the measure of central tendencies, the what? The mean, the mode, am I right? And the median, so we learn that. And also what? The spread. They do a standard deviation, okay, variance and deviation. So that's what they're talking about. So as a picture, they can see how data is being handled, how data is being used, analyzed to get the meaningful information there. Just one slide to summarize what they are about to learn, in other words. So same, followed by the exercises, whatever that is. Okay, now, I also say that, try to make clear meaning of some of the key words or key concept, whatever that is. So, this one is on the statistics of the combined events, by the way. Now, this is from the original one, okay? And I use the same one, no change. You can see that, okay, this is the same one, I'm just using it. Now, when I revise it, I keep everything the same as before, no change, exactly the same. You can see it all exactly the same. But I throw in a slide explaining these two words in statistics. And all are different meaning compared to what we use in our everyday life. These are special terms we use in probability. So I explain what's the meaning, and I use example. I use a previous example to illustrate the meaning of and all. When you see, the kids always get confused. When to multiply probabilities, when to add probabilities. Am I right? Sometimes they add together, sometimes they multiply together. Hey, when should I add? When should I multiply? And all is the key point for them to understand. When to add probabilities, when to multiply probabilities. So that's basically what I'm doing then. Okay, very briefly. So that's it. I'll touch it very quickly as I said.